EDA, Exploratory Data Analysis, is one of the most important and vital skill for a data analyst. If you are a data analyst or you want to become a data analyst, or even you want to become a data scientist, even if you want to become an AI engineer, EDA plays a vital role because that is one of the stepping stones towards your next targets or your next goals. Without EDA, you cannot really go ahead with your next steps. So understanding EDA is very, very important. And EDA is not just about performing univariate, bivariate or multivariate analysis. EDA is way beyond that. As the name suggests, exploratory data analysis is one of the most important skills where we actually indulge with the business stakeholders or even the clients to get the data, understand the data, what the data is telling us, and then insight gathering. And while doing all these steps, there are multiple things that we perform. That includes data cleaning, data transformations, data preparation, outlier treatments, understanding whether data is following a normal distribution or not, and way beyond that. Feature encoding, feature scaling, lot more things comes into EDA. So it is just not doing univariate, bivariate or multivariate analysis. Now talking about where do we learn EDA. There are multiple videos, multiple blogs where you can go through and understand EDA. But what you will not find on the internet freely is a structured program. Now in this video, we are going to talk about EDA and we are also going to talk about each and everything about EDA. This video is going to be a long video because we have divided the entire scope of EDA in multiple short videos. So go through this particular course, go through this particular video, and I'm pretty much sure you will be able to understand each and everything while we do the EDA processes. Of course, what's next after going through this video is you have to pick a use case and start performing EDA. Now to get an idea on your portfolio projects around EDA, there are many videos on my channel. In case you still need any help, let me know in the comment section below on which area you want to perform EDA and I can guide you accordingly. So let's get started. I wish you all the best if you are in your data analytics journey. This video is definitely going to be very much helpful. Don't forget to like, share and subscribe to the channel. See you in the video. Hi, welcome to this module on exploratory data analysis. We all know when it comes to solving a data analytics or a data science problem, it all starts with the business understanding part. Then comes our data understanding. Then comes our data collection, data preparation. These are one of the most important steps that we all know in the field of data analytics. Before getting into the actual analysis process, first of all, we need to understand the business problem, then the data understanding is must, and then only we get started with our data collection part. Data preparation is again one of the steps where we prepare the data. We take unclean data and finally clean the data. The output of the data cleaning and the data preparation part is the clean data. And that's where EDA comes into picture. So EDA expects that the data is cleaned so that it helps us in analyzing the data. And the output of EDA are all insights. Whatever the data is trying to tell us. EDA is by far one of the most important fields, one of the most important areas, one of the most important modules when it comes to the data analysis part. Talking about EDA, in this particular module, we will be learning what is exploratory data analysis, why EDA is important to us, what is the power of visual analytics or in simple terms visualization. We will also be talking about some of the important charts for visualization. What are the different steps involved in EDA, starting with data sourcing, cleaning, some univariate, bivariate analysis, which is basically your categorical data analysis, and we will also talk about some numerical data analysis, and then we will talk about derived metrics. After we go through each and every topic, finally we will be talking about some of the use cases that are applicable for EDA. And lastly, we will be going through one of the use cases and we will be explaining you how to perform EDA for that particular use case using Python. Hi, in this video we shall be talking about the data analytics or science process. Now this particular flowchart will give you a better understanding on how exactly things works. Generally speaking, we already know it's all about business understanding, then data understanding, then data collection, preparation, EDA, and model building. But in some of the cases, that does not give you the right picture. This particular flowchart is more close to how to solve an actual problem statement, how to solve an actual problem in a real world scenario. Now, there are multiple things we need to discuss in this particular flowchart. I am pretty much sure that by the end of this video, you will have a better understanding on what exactly is EDA, what exactly are model building processes, and how this entire data analytics or data science process works. It all starts with data. Data is most important to perform any kind of analysis or to create a dashboard or to create a model. Without data, nothing is possible. So, it all starts with the reality. Reality basically means what type of data do we have? Do we have a database? If we don't have a database, from where can we get the data? Is it through web scraping? Is it directly through some clients? So whatever medium or whatever source the data comes from, that depends and changes from scenario to scenario. At some scenarios, you might have to extract the data from your own company's database. In some scenarios, you have to do web scraping. In some scenarios, your client will be providing you the data. So the first step is always the data collection part. The data that is collected initially is all your raw data. Now, from the raw data, the next step is always data processing. Data is being processed. Data is being processed and prepared. Now, in this preparation step, the output is always a clean data. What do we perform here? There are multiple things that are performed. For example, the data that you have captured is having 200 columns or 100 columns. Now you know using your domain knowledge that you don't need 20 of these columns. They are not relevant for the problem statement. So you get rid of them. There are some missing values, you want to get rid of them. There are some invalid data types. There are some special characters which you want to get rid of. So there are some techniques that we follow here to clean the data. The output of the data processing part is a clean data. Clean data goes as an input for your EDA process. In the EDA process also, using some sort of analysis, let's say outlier detection or probably any other analysis we come across and we find that, you know what, out of the 80 columns that are present, probably 10 or 15 are not relevant. And that you finalize based on your analysis. So again, you have to go through this data processing step. So in short, this data processing, data cleaning part and the EDA part is kind of an iterative process. You process the data, then get the clean data set, then do EDA. While doing EDA also, you realize that there are some of the data sets or some of the columns that are not relevant, some of the rows that are not relevant, some of the records that are outliers. I need to get rid of them. You again come back, again do the data processing part. So ultimately, after doing this iterative process, let's say finally you have done your EDA. Finally, you have done your exploration of data. So your insights are with you. You know the problem statement and you know what are the possibilities why this problem has occurred. After EDA generally comes your model building part. In some cases, in some companies, in some scenarios, you do not have to do the EDA. Directly from the clean data, you can take and start with the model building part. EDA is not important in some of the scenarios. But if you do EDA, that is a better scenario. That is better thing to do. So after EDA or without EDA, finally you take the clean data and try to do the model building part. And this is where your machine learning engineers or data scientists come into picture. After your model is prepared, after your algorithms are set, then you prepare your final data product. Then you finally visualize the report. Using some Power BI or Tableau or probably Python, you kind of create some visualizations that you showcase to your end customers or to your higher management. And based on that, you finally take some decisions. So that is how the entire data analytics and data science process happens. So in this particular module, definitely collection of data is little bit difficult to cover because there are so many scenarios, so many things that can be done in the collection part. We will mostly be focusing on the data processing, data cleaning and the EDA part. So by the end of this particular module, you will have a clear picture on how data is processed, cleaned, and how the data analysis is done, EDA is done, and how do we get the insights from the data, what data is trying to tell us. So that's all about this particular end-to-end process. In the next video, we shall be talking about few other topics related to EDA, what is EDA, what is visualization, steps involved in EDA, and so on. What is exploratory data analysis? In simple terms, we call it as EDA. Exploratory data analysis is an approach to analyze the datasets to summarize their main characteristics in the form of visual methods. EDA is nothing but a data exploration technique to understand various aspects of the data. The main aim of EDA is to obtain confidence in a data to an extent where we are ready to engage a machine learning model. EDA is important to analyze the data as it is a first step in the data analysis process. EDA gives a basic idea to understand the data and make sense of the data to figure out the question you need to ask and find out the best way to manipulate the dataset to get the answer to your question. Exploratory data analysis helps us in finding errors, discovering data, and mapping out data structure, finding out anomalies. Anomalies are nothing but outliers. Exploratory data analysis is important for business process because we are preparing data set for deep, thorough analysis that will detect your business problem. EDA help to build a quick and dirty model or a baseline model which can serve as a comparison against later models that you will build. What do we understand with this? In simple layman's term, EDA is one form of a step or an approach which is used to analyze datasets so that we can analyze datasets and get some insights out of it. And the insights has to be in the form of visual, because the EDA insights, the output of EDA has to be presented to a higher management or to a client who might not be able to understand or interpret well from a Python code. So it has to be visually appealing so that a non-technical person who has no idea about data analytics or data science will be able to understand what the data is telling us. Whether a person staying in Japan is more likely to churn or a person staying in Indonesia. Whether males are more likely to churn than females. If yes, why? Whether somebody who has been doing a payment through credit cards are more likely to churn. What is the reason behind it? So ultimately, EDA is simply nothing but an approach to analyze your data to summarize their main characteristics in the form of visual methods. What is visualization? We all know visualization and what is the power of visualization, because ultimately in the field of data analytics, visualization is very important because that is one of the ways how we showcase our insights to the end customer or to a higher management who might not have that much of knowledge into Python. Visualization is simply the presentation of the data in the graphical or visual form to understand the data more clearly. Now, if you talk about, let's say I have data and there are multiple columns, one of the columns is age. If somebody asks you, what is the characteristics or what are the summary statistics that you are getting from age, then you tell that age, the mean age is basically 25. The 25th percentile is your, let's say, 32. The 75th percentile is 50. The median value is 27 and the maximum value is 92. Or else, if somebody asks you, can you give me details about the gender? You probably tell that male are 1400 and female are like 2000. Whether this is a better way of showcasing or this, definitely a visual technique or a visual way is more intuitive and more attractive for an end customer to understand about the data. Anybody can clearly understand that, females are larger in number. Probably females are way more than the number of males. Or else, if you want to visualize in another way using a pie chart, then also you will be able to understand that female are more in numbers than male. Using numbers also we can interpret, but visual form is always a better form to showcase the data. So visualization is nothing but the presentation of the data in graphical or visual form to understand the data more clearly. What are the advantages of visualization? Easily understand the features of the data, easily analyze the data and summarize it, help to get meaningful insights from the data, and help to find the trend or pattern of the data. What are the different types of visualization that we use? There are different types of visualizations. For example, we'll talk about a bar chart. Let's say you have a column like gender. You can easily plot a bar chart to showcase the distribution of male and female. The same can also be done using a pie chart, male and female. Imagine you are analyzing a numerical column. What is the distribution of age? Can I use a bar chart? Probably the age could vary from 18 to 90. In that case, you will end up having 72 bars, which is a little bit difficult to interpret. So, a better technique is to use a line chart, which will be able to tell that there is a spike between 22 and 25, which means most of the people are within the range of 22 to 25. Let's say you are analyzing height versus weight, two numerical features. Definitely you can take help of a scatter plot to understand the distribution of the data and what is the relationship between height and weight. In this graph, it is quite evident that when the weight is increasing, the height is also increasing, which means there is a positive correlation. So there are different types of charts including bar charts, pie charts, line charts, area charts, box and whisker plots, violin plots, scatter plots, pair plots, and a whole bunch of different other plots and diagrams and visualizations that we can use to summarize the data or to showcase what the data is telling us. So visual analytics is one of the most powerful analytics in the field of data analytics. And we usually go for this technique, go for the visualization technique to showcase our insights to an end customer or to our managers. Hi, in this video we shall be focused on the steps involved in the EDA process. The first step is all about data sourcing. What do you mean by data sourcing? Data sourcing is the process of gathering data from multiple sources as external or internal data collection. There are two major kind of data which can be classified according to the source. One is public data and one is private data. What do you mean by public data and private data? Public data is the data which is easy to access without taking any permission from the agencies. The agencies made the data public for the purpose of research. For example, multiple government websites and other public sector or e-commerce websites that make the data publicly available. You can easily extract the data, download the data, or use some web scraping techniques to get public data for your analysis. The second type of data is private data. The data which is not available on the public platform, and to get access to the data we have to take permission of the organization. Now for example, you are currently working with a telecom company or a banking company. You have to work on multiple banking use cases. In order to work on such use cases, you have to reach to your own organization's DBA team, which is your database administration team, to help them give you access for the data. Once they give you the access to the data, you can either download it or create a connector to use the data for your analysis process. But depending on the use case that you're trying to solve, you have to choose your data source wisely. If I also talk about one of the scenarios, talking about different companies, there are different types of companies. One of them being MNCs, which are your multinational companies. Most likely, when you are working as a data analyst or as a data scientist in an MNC, there could be multiple databases that the company must be handling. Based on the type of data you need to go and talk to each of these database administrators so that they can give you access to the data. Once you get access to the data, then you can start working on your EDA and then work on the model building part. If you are working for a mid-level company, again, mid-level companies might not have huge databases like MNCs, but still they would be having some databases. Again, the process is same. You go ahead, take access, and then start working on EDA or model building. In small level companies or in startups, there are again further two steps. One is a startup is a mid-level startup. Then again you have to follow the same technique like this. If the startup has a database, go ahead and get access to the database and start working. If the startup is completely new, in that case there are two further scenarios. One is the startup has a client and one the startup has no client. If the startup has a client, there is a possibility that the data must be taken from the client itself, and then you can perform your EDA and model building part. And if you don't have a client, then you have to get help of the public data to either do some web scraping technique or get some data from some government or some open public sector websites, and then start working on your model building or the EDA process. So depending on the type of company you are working, depending on the type of use case that you are handling, you need to understand what should be your data source. And based on that, you should get the data for the next processes. After data sourcing comes the next process, which is basically your data cleaning process, which will be explained in the next video. After data sourcing comes your data cleaning. Once you get the data, then comes your data cleaning process, which basically takes the unclean data and gives you a clean data. What do you mean by data cleaning? After collecting the data, the next step is data cleaning. Data cleaning means that you get rid of any information that does not need to be there and clean up. Data cleaning is the process of cleaning the data to improve the quality of the data for further data analysis and building a machine learning model. Initially, you get the data, then you clean the data, and once the data is clean, either you go for EDA or you go for the machine learning model building part. Sometimes you go through EDA and then go to the machine learning, and sometimes you directly go to the machine learning. But whatever you do, either EDA or this is a prerequisite and one of the important steps. Data cleaning is very important. The benefit of data cleaning is that all the incorrect and irrelevant data is gone, and we get the good quality of data which will help in improving the accuracy of our predictive models or machine learning models. What are the major steps that we involve in the data cleaning process? The major steps are handling missing values, standardization of the data, which in simple terms we call it as feature scaling technique. We also have outlier treatment and handling invalid data types or handling invalid values. Most time, once we have the data, we usually have missing values. Missing values could be because of multiple reasons. It could be actually be missing in the database or the data source, or it could be a missing value because of the scripts. Maybe you have written down a script to get data from the database, and while that process happens, due to some reasons, you have some missing values. The reasons of having missing values are multiple, but in order to analyze it, in order to do some further activities, we always have to impute these missing values. Either we delete those records or we impute them. We will be learning through each of these processes as part of separate videos. After missing values, we also have a technique called as feature scaling. Again, feature scaling is an important technique. We will be studying about feature scaling, which basically has standardization and normalization. Two different techniques. And most of the data that we deal with definitely have outliers in it. What do you mean by outliers? In simple terms, if most of your data points are within this range and some of the data points are scattered way above or way below than the rest of the data points, these data points are called as outliers. Sometimes we have to treat outliers. Either we get rid of them or we deal with it. And sometimes we also have invalid values. Invalid values, like let's say you are dealing with age. There is a age like minus 180, or there is some columns where you have some special characters. You have to deal with these situations. Sometimes you have a date column, but the date you have is not in a date format. So there are multiple scenarios that could occur here, and we have to deal with it as part of the data cleaning process. In the next video, we shall be talking about each one of these steps in detailed manner. See you in the next video. In this video, we shall be talking about how to handle missing value issue. When it comes to the data analysis part, in the data cleaning part, missing values are one of the most important common issues. How do we get rid of them? Let's try to understand theoretically, and going forward, we will also show you how to deal with missing value problem in Python. There are multiple techniques to handle missing values. The first technique is either you delete the rows or columns. This method we commonly use to handle missing values. Rows can be deleted if it has insignificant number of missing values. Column can be deleted if it has more than 75% of missing values. Now, there is no thumb rule on whether you should delete rows or columns. But there are some techniques. Let's say you have data. Now imagine one of the columns is there which has no dependency on any other column. And this column has already like 50% of missing values. There is no need of imputing this column. It's better to delete that column. Or else, if you're dealing with data and some of these records are having missing values, some of the rows are missing, maybe just 2% or 3% of the data are missing. Now in this case, either you impute them or you delete them because it's too less. Comparing to a 10,000 records data set, 2% is nothing. 1% is almost 1% is almost 100 and 2% is almost 200 records, right? So 200 records, even if you delete them, of course you are missing out on information. Ultimately you will be having 9,800 records, but it all depends whether you are imputing it or deleting it. In certain scenarios we delete it, in certain scenarios we impute it. If it comes to imputing, that means replacing the null values. What is the right way to replace? Sometimes we go with some arbitrary numbers. Now for example, we are dealing with a column called as age. Sometimes we randomly fill a random value, let's say 25. Let's try to fill 25 in all the missing values that we have. That technique also works. But is this the right technique? No. I would say it is one of the idiotic techniques to fill a random number into age. A better technique is to use the mean or median values. For example, age has a certain mean. For all the values that it has, let's say the mean is 32 point something. So if you impute the records with the mean value, that is 32, makes more sense than imputing a random number. Similarly, in certain scenarios, we also impute the median value. Let's say the median value is 31. You impute them. Mode is mostly used for categorical data. Which of these techniques is good? Mean or median or mode? It all depends. At least for the process of EDA, you can impute any of these numbers. If you are building a machine learning model or a predictive model, in that case you are dealing with this missing value problem. In that case, there is no right or wrong. You should always do a hit and trial. That means you have data. Let's say the age column you are imputing with mean. Go ahead and build the model and check the model's accuracy. Let's say the model's accuracy is 80%. Again come back, impute it using median. Again build the model and check. If you see an increase in accuracy, probably you can finalize that median is a better technique. In certain scenarios, we also go for algorithmic imputation. That means when your ultimate goal is to build a predictive model or a machine learning model. Some machine learning models or some machine learning algorithms supports to handle missing values. That means they do not care about the missing values. Even if you have missing values, you just call these algorithms and they will be able to handle that internally. So if your final goal is to create a model, create a predictive model, in that case, you can also go for this algorithmic imputation. But as in this case, we are only focused on the EDA part, on the analysis part. We will not be considering this particular technique. We will only be considering these techniques like mean, median, and mode. There are also some advanced techniques to handle missing values. Some of the advanced techniques are predicting the missing values using some time series forecasting problem. Prediction model is one of the advanced method to handle missing values. In this method, dataset with no missing value becomes training dataset, and dataset with missing values becomes the test dataset, and the missing values are treated as target variable. Which basically means, just imagine you have data and let's say out of 10,000 records or out of 1,000 records, 200 are null records for age. Then what we do is we usually take those 800 records and try to do prediction for these 200. And once the predictions are done, these predicted values are taken into consideration, and then you perform your EDA or model build. Now this technique is an advanced technique. You can or you cannot use it, it's up to you. That's all about this particular session on handling missing values. Let's go ahead and see the Pythonic part and on how to handle missing values using various techniques. Jumping on to the Python part, jumping on to the practicals part on how do we actually handle missing values in real-time scenario. For this particular exercise, we have a data set called as churn modeling dataset. We'll try to quickly see what the dataset is all about. We have manually created some of the null values in that particular dataset so that we can handle that missing value, and probably I will tell you different techniques on what we should do and what we usually do while in this journey of the data cleaning process. So we'll get started by importing all these libraries, pandas, numpy and matplotlib. As you can see, I'm using Google Colab. So I have just right clicked and uploaded the churn modeling file here, and here I'm reading it using /content/ the churn modeling file. The moment I run, my data frame is ready. The first thing that I can do is .info, which will clearly give me a quick information about the entire data set. We have manually created some null values for these two columns, but you can see it's quite visible. Gender, we have 54 null values, and for age, we have almost 300 null values. How much percentage is 300 out of 10,000? If you start calculating, 300 divided by 10,000 is almost 3%. 3% of null values. So these are the insights that are written here. The second way of finding whether we have null values in the data is by using the isNull function. Simply you can print dataframe.isNull.sum. The moment you print in, you will be able to get something like this, which clearly states that gender has 54 null values and age has 300 null values. Now we know that our dataset has null values. What's next is how to handle them. So there are different techniques that are mentioned here. The first technique is deleting the columns with missing data. First of all, I have created a new data frame and I am doing df.dropNA axis equals to 1. The moment I run this and then I do updated df.info, you can see that my two columns are gone. I don't see gender and age anymore here. Initially there were columns ranging from 0 to 13, so almost 14 columns, and now we have 0 to 11, that is 12 columns. So age and gender has been dropped. Is this a wise decision to do? In this particular scenario where age has 3% null rates and gender has less than 1% of null values, it is not a wise decision to drop these columns because they could be carrying a lot of information. The problem with this method is that we may lose valuable information on that feature as we have deleted it completely due to some null values. Should only be used if there are too many null values. Second technique is deleting the rows with missing data. So I'm again creating another data frame, df.dropNA axis equals to 0. Axis equals to 0 means it will only be deleting the rows. Now you can see when I'm doing .info, whichever rows, let's say I have a data. I have multiple columns. We'll talk about 4 columns. this particular record is null value. That means this entire row is deleted. This particular value is null value. That means this entire row is deleted. This is what is done here. So we are left out with 9,662 records. In this case, there are possibilities of getting better accuracy than before. This might be because the columns contains more valuable information than we expected. So usually when we go ahead with the machine learning model building or the predictive model building, this can be an accepted way. You can delete these rows, that is fine, because some of the columns in these rows are null. But again, there are some better techniques as well, which is imputation. And as we told, when it comes to predictive analytics or machine learning part, nobody can really tell you which technique is the best, whether the deleting rows is best or deleting columns are best or imputation is best. It's all about hit and trial. Moving on to the next technique, which is filling the missing values, imputation. In this case, we will be filling the missing values with a certain number. The possible ways to do this are filling the missing value with the mean or median value. If it is a numerical variable, if it is a categorical, we will use mode, or else some idiotic approaches are to randomly fill it with some random data. Now, how to calculate the mean of the age column? You can see I'm just calling the df of age dot mean, which is 38.89. What is the median? The median is 37. So here what I'm doing is I'm creating a data frame called as updated df, taking the help of df. In the updated df for the age column, I'm doing updated df of age dot fill na. What I am filling? I am filling the mean value. Try to remember this fill na. Fill na basically fills the null records. We also have drop na. Drop na basically means drops the null records. In this case, we are filling the null values with the mean value. Now, if you do this and then you do the updated df.info, you can see the age records are treated. Now, age does not have any null values because you have already treated it. Similarly, I will now treat it with median, and you can see upon treating it with median, again the age null values are gone. Which of them is good, mean or median? The concept remains the same. There is no thumb rule that mean is better than median or vice versa. Sometimes when you have too many outliers, it is better to use median. When you have less outliers, it is better to use mean. Some other techniques are forward and backward filling, which basically means this. You have a data set, and I'm talking about age. So age, let's say 25 null, 29, 30 null, 35. Forward filling and backward filling means this value gets updated here, so it becomes 25. This value gets updated here, this becomes 30. Or else other way around. This value gets updated here, 35, and this value gets updated here, which is 29. So there are different techniques using which we can impute. Which of them is the best technique? It's all about hit and trial. The more hit and trial we do and then build our models, we'll probably be getting more understanding that this is the better technique. But as we are into the EDA process, we just have to learn what are the different techniques to handle missing values, because in analysis, we don't have to understand which is best, which is not best, which technique is good, which is not good. So I'll be reading this data frame, df.info. Again, you can see null values. I'm creating another data frame, and in this new data frame, I'm using the bfill. Okay, backward fill. And you can see once I'm doing backward fill, my values are being updated. My age values are being updated. And similarly, if you want to do forward fill, just simply change it to ffill. That's it. Apart from that, as we already discussed theoretically, that there are some time series forecasting algorithms as well, which are very advanced techniques. We usually understand it theoretically. In practical applications, the amount of efforts we spend in doing that technique, we can actually ignore that and focus more on the model building part. So we usually don't do that technique, we don't apply that technique, but theoretically I will try to explain what do you mean by that time series forecasting technique of handling missing values. Imagine you have a column date, and let's say you have salary or sales. Sales is a better column. You have Jan 1, Jan 2, and you have different sales value, $120, $150, $110, $80, and all these are in millions. Okay, $70 null value, $80 null value, $120, $130 null value, something like that. Now this technique can be very tedious, that's why we don't use it practically, but theoretically try to understand this. What happens here is, to impute this null value, we can take these 5 records, insert it into a time series algorithm, and then do a one-step prediction. Let's say the predicted value is 90. This prediction goes here. Now next step, what happens is, we take all these values, 120, 150, 110, 80, 70, the predicted value 90, 80. Using them, again I call another time series algorithm. Again I do a one-step prediction, whatever the value I impute here. Same goes with here, and this process goes on. Imagine you have at least 100 null values. You will be creating 100 algorithms. And creating an algorithm could be tedious in terms of time consumption. It could be tedious in terms of memory consumption as well. So we usually don't put more efforts in these kind of techniques, rather than we go for mean, median or mode techniques. So that's all about this particular video on handling missing values. I hope you understood this. In the next videos, we shall be talking about few other techniques that we follow in the data cleaning process. The next technique that we are going to understand is feature scaling. And this technique is also used as part of the data cleaning process. However, feature scaling is more important when it comes to predictive model building. But sometimes we also use it in the EDA process. Let's try to understand what exactly is feature scaling and why feature scaling is important. Feature scaling is the method to rescale the values present in the features. In feature scaling, we convert the scale of different measurements into a single scale. It standardizes the whole dataset in one range. Importance of feature scaling. When we are dealing with independent variable or features that differ from each other in terms of range of values or units of the features, then we have to normalize or standardize the data so that the difference in range of values doesn't affect the outcome of the data. As I told you, feature scaling is very important when it comes to predictive modeling or predictive analytics. When it comes to the EDA part or the descriptive analytics part, well, it depends on how important this technique is, but let's try to understand why do we need feature scaling. So imagine you are analyzing some data. And that ultimately you have to feed this data to your machine learning model or to your predictive model so that the model can understand the data and be capable enough to predict something. Now, your machine learning models or algorithms are nothing but run on computers. And what is the most accepted format of computers? The most accepted format is bytes, which is in the form of zeros and ones. Computers don't understand categorical data. They don't understand any characters. They only understand numerical values. So imagine I talk about a feature called as height. Let's say I have 5 customers or 5 people and the heights are something like this. Now if I ask you what is the units of height, and I give you an idea that these are human beings. I'm analyzing people. I'm analyzing customers' data. When I see this column, it is quite obvious that I know that these are in centimeters. Why? Because we have been trained with so many data till now. We know that if it is in hundreds places, it is in centimeters. If it is something like this, we know that it will be in meters. If it is in like this, we know it is in feet and inches, right? Let's say I'll talk about weight. We are analyzing customers' data. Let's say somebody's weight is 85. We know that it has to be kg. In very rare scenarios, it will be lb. But it has to be kg. It cannot be grams. It cannot be any other units. So ultimately, these numbers matter. If you have 2 columns, height and weight, imagine you have this column and this column. Somebody is having 80, 90 kgs, 65, 60 and 75. If you feed this data to your machine learning models, there are high chances that your model will try to give priority to height, because height is larger in number. It is in 100 places. These are in tens places. So in order to neutralize that concept, in order to deprioritize that, so that machine learning algorithms or your predictive models do not prioritize any column given their data, we should always go for the feature scaling part. If you scale down all the columns, all the numerical columns to the scaled values, then we know that they are right now in a proper scale. We'll take a small example to let you understand more about this concept. Let's say I have weight 85, 80, 75, 70. I'll give some space so that I can have the feature scaled value. And next I have height. And I will have the scaled height value. Let's say height is 170, 165, 168, 170. These are 4 people, right? Now, what is the, let's say this is person A, person B, person C and person D. Now my question here is, which person has the highest weight? A has the highest weight. Which person has the lowest weight? D has the lowest weight. Lowest. Highest height? A and D both have highest height. And lowest height is B. Understood? So these are the features that we are analyzing, right? A and D are having highest and lowest weight, and A and D combined have highest height, and B has the lowest weight. Now let's try to scale it down. Now I want to scale it down in a range of 0 to 1. So what I will do is I will divide each number by the highest number. So the scaled value will be 85 by 85, which is 1. 80 by 85, which is, let's say, 0.95. We'll try to take help of calculator. 80 by 85 is 0.95. 75 by 85. 75 by 85 is 0.88. And 70 by 85 is 0.82. Now, these are all my scaled values. What is highest here? Person A. Still the same with the original value. Lowest value is person D. Same. So you can see the feature's importance is not changing. The importance of each feature is same. A used to be the highest weight, D used to be the lowest weight. In the scaled down values also, A is highest and D is lowest. Same with the height one. 170 by 170 is 1, 1. 165 by 170, 165 by 170 is 0.97, and 168 by 170 is 0.98. You can see this is still the highest. 170, 170. Person A and D still the highest, and person B still the lowest. So you can see that the feature importance is not decreasing. However, we are coming up with new features which are nothing but the scale down values. Now you can see weight is in tens value and height is in hundreds places. But the scale down values both are within the range of 0 to 1 and 0 to 1. So these are most accepted when it comes to the model building part. Feature scaling is blindly one of the most important techniques when it comes to the model building part in the predictive modeling part. However, in the field of EDA, at sometimes we perform feature scaling and sometimes we do not perform feature scaling. But understanding feature scaling is very important. Majorly, one of these techniques I already told you, that divide every value with the maximum value, that can also be a feature scaling technique. But the two most accepted techniques, two most accepted feature scaling techniques when it comes to statistics is, one of them is standardization and one of them is normalization. Standardization and normalization. The formula of standardization and normalization is very simple. Standardization follows the same technique. You must have remembered this normal distribution and the standardized normal distribution, right? Z score used to be x minus mu by sigma. Now that's what your standardization is all about. And normalization is the normalized value is x minus x minimum divided by x maximum minus x minimum. So talking about the theoretical concepts, standard scaler ensures that for each feature, the mean is 0 and the standard deviation is 1, bringing all feature to the same magnitude. In simple words, standardization helps you to scale down your feature based on the standard normal distribution. And normalization helps you to scale down your features between a range of 0 to 1. Which of these techniques are more powerful? If you know that your data is somehow following the standardization technique, the normal distribution technique, you should always go for standardization. If your data is not normally distributed, you should go for normalization. That's all about this particular topic on feature scaling. In the next video, we shall be jumping into the standardization and normalization part separately, and then we will talk about the Python part. How do we implement feature scaling using a sample data, and how do we perform the standardization and normalization? See you in the next video. Let's talk about our first feature scaling technique. In this video, we shall be focusing on the standardization part. We'll try to take an example and show you how standardization can be performed. And going forward, we'll also have a session on how to apply standardization and normalization both using a Python code, using a sample dataset. Just to repeat once again, standardization in statistics is the process of converting data to z-score values based on the mean and standard deviation of the data. The standardized data will have mean equals to 0, and the values will generally range between -3 and +3. Almost 99.7% data will fall. We all know about normal distribution, which basically lies between mu plus 1 standard deviation plus 2 standard deviation plus 3 standard deviation, and going on the left hand side also -1 standard deviation, -2, -3. 68% lies here, 95.4 lies here, and 99.7% lies here. Now this graph on the scale of z-score is nothing but 0, 1, 2, 3, -1, -2 and -3. That means between the range of plus minus 3 z value, 99.7% data lies. This formula of z-score is very simple. Z-score is nothing but x minus mu divided by sigma, where mu is the mean value and sigma is the standard deviation. Sigma, we all know sigma formula is summation of xi minus mu square divided by n in the case of population and n minus 1 in the case of sample. So taking this example, on the screen we have age, we have income. So let's say we are going to standardize the income part. So let's say I have income as 15,000, 12,000 and 30,000. What will be my mean value? My mean value will be sum of 15,000 plus 12,000 plus 30,000 divided by 3, which is 27 plus 57 by 3, which is almost 19,000. So if I talk about x minus mu by sigma, before that we also should calculate the sigma. Using the sigma formula, summation of xi minus mu square divided by n, you can also calculate the sigma value. In this case, the sigma value is 9643.65. So if you do this, which is 15,000 minus the mean value divided by the sigma, same with here, and finally you will be getting the standardized value, which is minus 0.4, minus 0.72 and 1.14, and these are all the standardized values and they are within a scale of something. That's how standardization looks like. So we have to calculate the mean value and then we have to calculate the standard deviation and then calculate the standardized value. When it comes to Python, we will be introducing one of the libraries which is called as sklearn library. Sklearn, inside that, has multiple methods which starts with standard scalar, min max scalar and so many other scalars which we will be using, which performs these activities. So that's all about this particular example on standardization. In the next video we shall be talking, we'll be taking a similar example and show you how normalization works, and going forward we'll have a separate session on the Python part. Let's take an example related to normalization. We all know what is normalization. The formula of normalization is x minus x minimum divided by x maximum minus x minimum. It's another way of scaling down the values to a particular scale, right? If you have multiple features with different numbers, one of the features is in tens format, one of the features is in thousands format. So when you pass these raw values to your machine learning or to your predictive model, they will be biased. They will be biased towards income. Within income also, they will be biased towards these larger numbers. So in order to have an unbiased model, we perform feature scaling. Let's try to take the same example and see how do we perform normalization in this particular example. So we have income 15,000, 12,000 and 30,000. In this case, we'll have to figure out what is the minimum value. The minimum value is this. The maximum value is this. So what is the income dash, which is the normalized value? X minus x mean, 15,000 minus 12,000, which is 3,000, divided by 30,000 minus 12,000, 18,000, which is 3 by 18, which is 1 by 6, which is 0.16 dot dot dot. Similarly, for the second one, the numerator will be 0, so it will be 0. For the third one, the numerator will be 30 minus 12, which is 18 by 18, which will be 1. So the normalized values are 0.16, 0 and 1. And as we all know that normalization always lies within the range of 0 to 1. The maximum value could be 1 and the minimum value could be 0. So that's all about normalization. In the next video, we shall be jumping into the Python part, and we will be introducing you some of the Python libraries that you might not know till now. We will be introducing them, installing them, and using those libraries, we will be performing the same standardization and normalization so that you can have some practical knowledge on these topics. That's all about this particular video on the normalization example. See you in the next video. Let's get started with the Python part. So as usual, I'm using Google Colab and I have just right clicked and uploaded my CSV file. In case you are using Jupyter Notebook, you can use your local directory, fetch the dataset and get started with this exercise. Or else there are other ways to import from a Google Drive as well. I'm pretty much sure you must be aware of those things. So getting into the topic of feature scaling. The first thing that we need to do for feature scaling is to install a library called as scikit-learn, which is also called as sklearn. In my case, I have already installed this library, so for me it is giving me an warning that requirement already satisfied, right? So I'll quickly get started with my exercise. I have imported all the libraries, which is NumPy, Pandas, Matplotlib, Seaborn, etc. And I have started reading the file churnmodeling.csv, and upon doing .info, this is what I'm getting, that it is having 10,000 records and these are the different columns. Some of them have null values, and then we'll get started. Gender has 54 missing values, age has 300 missing values. Here I'm importing the standard scaler and min-max scaler. These are the two things that's important for sklearn, and using these two functions, these two methods inside the sklearn library, you will be performing standardization and normalization. So this standard scaler is basically the standardization technique, and this min-max scaler is basically for the normalization part. If you want to know more about this, probably go ahead and just search sklearn standard scaler. You will be getting the documents, official documentations of scikit-learning, and you can go through this particular page to understand more about standard scaler. Standardize features by removing the mean and scaling to unit variance. The standard score of a sample X is calculated as Z equals to X minus mean divided by sigma, which we already know, right? And the same goes with normalization also. If you just search sklearn min-max scaler, you will be getting their official documentation. Go ahead and you will be able to understand about this particular thing. Transform features by scaling each feature to a given range. Now going ahead, we all know what is normalization and what is standardization. Normalization is a scaling technique in which values are shifted and rescaled so that they end up ranging between 0 and 1. It is also known as min-max scaling. What is standardization? It's another scaling technique where the values are centered around the mean with a unit standard deviation. This means that the mean of the attribute becomes 0 and the resultant distribution has a unit standard deviation. First of all, I want to let you know how our data frame looks like. In order to show the data frame, I will just print dot head. And you can see I have row number, customer ID, surname, blah blah blah, so many columns. One thing you must notice is some of these columns are having categorical values, and some of these columns are not important for our analysis. Now just in case your columns are not important for your analysis, simply remove them. In this exercise we are not focusing on that part. we are focusing majorly on how to perform standardization and normalization. That's why I will not be showing you all those things. So what I will do is I'll quickly do the dot describe method, which basically shows the statistical information of all the numerical columns. I will choose some of these numerical columns, maybe age and tenure, and using them I will be doing the normalization. So task 1, we will be talking about normalization. That's how my DF looks like. I am creating a new data frame only with age and tenure. That's it. Only age and tenure. I don't want any other things. So how does my new DF looks like? My new DF looks like this. Obviously these are only 5 records, but you know that this is in ones place and this is in tens places, right? As we have some null values, we are imputing the null values here with the mean value. So once I run this, my null values are gone. If you just want to cross check after this, just do info and you will see that there are no null values anymore. Done. Now this is where I want to call my min max scalar. So scalar equals to min max scalar. Now this line is basically I'm instantiating the min max scalar function. I'm initiating that function. Now I have a variable named normalized df equals to scalar dot fit transform new df. So I'm calling the scalar dot fit transform. Fit transform basically fits and transforms the data. It basically does the conversion part, z equals to x minus mu by sigma, and then it fits the data. You will understand more about fitting data probably when we jump into the predictive analytics part, but for now just imagine that this is fit and transform. We basically convert the data and fit it, and you can see the normalized df looks like this. Okay, min max scalar is not defined. We'll have to define it again, and then we will run this, and you can see that's how my normalized data looks like. And obviously they does not look like this, right? They are, both of them are in a similar scale, right? Now you might not be able to understand what's happening inside, right? There are so many values. We have 10,000 records. So we'll try to take a small example. Mathematically I will show you how things are happening, and I will also show you the output here. You can see I have taken an array of 5 objects 2, 3, 5, 6, 6, and I'm calling the min max scalar, and I'm calling the fit transform, and I'm printing the normalized array. That's how my output looks like. So let's try to do it using Notepad, using paintbrush. So we have data, so I will write it down as x array 2, 3, 5, 6, 6. What is normalization? X dash equals to x minus x minimum divided by x maximum minus x minimum. Simple. So what is the numerator part? X minus x min, sorry, we'll talk about the entire thing, okay? What is the minimum value? This is the minimum value. The maximum value is this. So for this, the x dash will be x minus x minimum, 2 minus 2, 0 divided by anything will be 0. This will be 3 minus 2 divided by 6 minus 2, which will be 1 by 4, which will be 0.25. This will be 5 minus 2 divided by 6 minus 2, which is 3 by 4, which is 0.75. This will be 6 minus 2 divided by 6 minus 2, which will be 1. 6 minus 2 divided by 6 minus 2, which will be 1. So the final values are 0, 0.25, 0.75, 1 and 1. And that is what it is. 0, 0.25, 0.75 and 1. And that is what is happening inside, right? So if you want to cross check on a big data set, probably you can cross check that. So that's all about normalization. Coming back to standardization, very similar technique. Instead of min-max scalar, here I'm calling my standard scalar and I'm doing the same operations. Exact same piece of code. If I run this, you can see my standardized values are this. Again, taking this example, same example, I will be using the standardization technique. So I will rub this off. I will again take my x value, which is 2, 3, 5, 6 and 6. What will be the mean value? The mean value will be 2 plus 3 plus 5 plus 12 divided by 5, which is 4.4. What is the standard deviation? Standard deviation is root over of xi minus mu square divided by n. So let's try to calculate. What is xi minus mu square? It is 2 minus 4.4, 2.4 square. It is 1.4 square. It is 0.6 square. It is 1.6 square. It is 1.6 square. So what will be the actual values? 2.4 into 2.4 is 5.76. 1.4 into 1.4 is 1.96. 0.36. 1.6 into 1.6 is 2.56. And this is 2.56. We'll just cross check for 1.4 into 1.4. 1.4 square is 1.96. My bad. 1.4 square is 1.96. Done. Now we'll try to add this up. How to add it? 5.76 plus 1.96 plus 0.36 plus 2.56 plus 2.56, which is 13.2. So my standard deviation will be 13.2 divided by, as this is we'll try to consider this as a population data, divided by 5. Divided by 5 is 2.64 and then its root over is 1.62. That's my sigma, right? So what is my x dash? My x dash formula is x minus mu by sigma. So this will be 2 minus 4.4 divided by 1.62. So let's try to cross check. 2 minus 4.4 divided by 1.62, which is minus 1.4. Minus 1.48. For the second one, 3 minus 4.4 by 1.62. 3 minus 4.4 divided by 1.62. It is minus 0.86. Minus 0.86. See, I am only taking 2 decimals. The actual value is more than 2 decimals, right? So these values and these values will not be exact replica, but you can see it's almost close. Here it is minus 1.47, here it is minus 1.48, minus 0.86, minus 0.86. We'll try to calculate for this one, which is 6 minus 4.4 divided by 1.62, which is 6 minus 4.4 divided by 1.62, which is 0.98. Obviously for this is also 0.98. So we'll calculate for the last number also, divided by 1.62, which is in 200, which is 0.37. 0.37. So you can see the x dash values are 1.48 minus 0.86, 0.37, 0.98 and 0.98, and you can see these numbers are matching. So that's all about standardization and normalization. As I told you, repeating once again, standardization or normalization is one of those mandatory steps before getting into the predictive analytics part. Talking about the EDA part, it might not be necessary, but it's important to know all these techniques. So that's all about feature scaling. We'll see you in the next video. Let's talk about the next type of data cleaning activity that we do, which is outlier treatment. In simple terms, outliers are the most extreme values in the data. It is an abnormal observation that deviates from the normal data. Outliers do not fit in the normal behavior of the data. Outliers are also called as anomalies. Now, how do we spot outliers? There are different techniques to spot outliers, but before getting into the detection part, let's try to understand what outlier is. Now, imagine there are different people with different age: 28, 29, 31, 92, 28. Now, if I simply plot them, most of them are in the range of 28 to 31, but one of them is far away from that particular distribution. This basically means that this data point is not a part of the regular distribution of the data, which makes it as an outlier, as a potential outlier. Similarly, let's say you are analyzing sales data. In the month of January, we did 120 million sales, then 150 million, then 130 million, and then suddenly one month there was a 10 million sales, and again we are back to track. So you can see in the month of April there is a downfall. Most of the data points are here, but in this April month you see a very high downfall. Now this could also be a outlier. So outliers are pretty much common in any kind of data. What needs to be done to detect outliers? There are different techniques to detect outliers. Now we shall be talking about each of these techniques. The first technique to detect an outlier is a box plot. Box plot is simply one of the plots which looks like this, where it focuses on 5 important factors or 5 important measures, one of them being minimum value, which is this, one of them being maximum value, which is this, one of them being a median value, which is this, 25th percentile and 75th percentile, which is this and this. It is also called as Q1 and Q3. Using box plots also, you will be able to identify the outliers. Let's say in this particular portion, 50% of your data lies. The data points which are lying around here could be your potential outliers. Using histograms also you can spot outliers. For example, you have age and you have different distribution, 28, 29, dot dot dot, and one of them is 92, dot dot dot, something like that. What if you spot, let's say you draw the graph, it looks like somewhere like this, and then somewhere you have a data point here. Or else if you convert this into a age bin, 25 to 31 age bin, 15 to 21 age bin, and based on age bins, when you are plotting the histogram, you potentially spot an outlier somewhere here. Using scatter plots also you can identify outliers. Let's say most of your data points are around this area, so it is quite evident that most of the data points are in this range, and the data points falling out of that range are the potential outliers. Another way of identifying outliers is the most classical way, which is the normal distribution curve. We all know that in a normal distribution curve, almost 99.7% of the data lies between plus minus 3 standard deviation. 1, 2, 3. 1, 2, 3. We all know that this is basically 99.7% data, right? This is plus 3 sigma and this is minus 3 sigma. What happens to the 0.3%, which lies beyond this, are nothing but your outliers. So there are different techniques using which we identify outliers. What needs to be done with those outliers is there is no thumb rule for that. That in this particular scenario we should get rid of this. In this particular scenario we should not get rid of this. Now I can give you some of the examples where you need or need not have to treat the outliers. The first use case is time series forecasting. Time series forecasting is one of those areas under predictive analytics where we use time series data to predict something. Just a simple example is, imagine you have been noting down the temperature of your country. Let's say you stay in Malaysia, you have date and you have temperature. Every day you are noting the temperature. Obviously, some of these temperatures could be outliers. Suddenly, in one of the days, there was 41 degrees. Suddenly, it was 17 degrees. Let's say. Now, if you are forecasting the value, let's say you have data for 6 months and you want to forecast for the next particular instance. So, you should always take care of these outliers. You should not drop these outliers because it's a time series forecasting problem and each data point is important. There could be an internal pattern that you are not able to understand where your models could be able to understand. So never get rid of your outliers, especially in a time series problem. There are multiple other scenarios. Maybe one of the scenarios could be if you are dealing with a data set and one or two people are basically falling in this category where their age is very high. Now in this case, if you want to remove, you can remove. If you want to keep it, you can keep it. There is no right or wrong. The process is very simple, exactly like the way we discussed earlier. When it comes to predictive analytics, it is a iterative process. It is a hit and trial process. First of all, you remove them, check the model's behavior, how the model is performing, again go back and then again add those outliers and see how the model is behaving. That is how we finalize our predictive model, whether it is behaving well with the outliers or not. Because going forward in the predictive analytics, you will learn a lot of algorithms which are not prone to outliers. That means they do not care about outliers. You can see the point number 4 where we have multiple algorithms like k nearest neighbors, decision trees, support vector machines, naive bayes, and some Ansible methods which do not worry about outliers. They are okay if the data is having outliers. So how do we handle outliers? Using following methods. Remove the outliers. Yeah, could be one of the techniques. Replace outliers with suitable values by using following methods: quantile method or interquartile range. Use that ML model which are not sensitive to outliers. Okay, so with due course of time, once we jump into practicals, probably you will have better understanding on where to keep the outliers and where to ignore the outliers. Especially in the field of predictive analytics, we should always do a hit and trial. There is no right or wrong. When it comes to the descriptive part or the EDA part, where we are just analyzing the data, in that case, it is completely fine whether to keep the outlier or not keep. That is completely fine. So that's all about the theoretical concepts behind outlier treatment. In the next video, we shall be talking about the Python part. How do we see an outlier using box plot, histograms, and how do we see using the normal distribution and all those things. So that's all about this particular video. See you in the next video. Bye bye. Hi, welcome to this practical session on outliers. In this video, we shall be talking about the different techniques that we use to identify outliers in data. So the first technique I am going to talk about is the 3 sigma technique, which is based on the principles of normal distribution, which we already know. Normal distribution is nothing but something like this, right? Where the middle value is your mean value, we have plus minus 1, plus minus 2, plus minus 3 standard deviation. Anything beyond your plus minus 3 standard deviation is treated as an outlier. If your data is perfectly following the normal distribution curve, then 0.3 percentage of your data will be your outliers. But as we know, normal distribution is a hypothetical scenario. Not all data can be 100% normally distributed. So your anything beyond plus minus 3 standard deviation could be any value ranging from 0.3 to X percentage. That could be even 1 percentage, 2 percentage. It depends how normally distributed your data is. So in this particular example, when I talk about 3 sigma technique, that basically means anything that falls beyond your plus minus 3 standard deviation is treated as an outlier. So we have created a function for this particular technique, and we will be passing the data, and we will be seeing what all data points are falling beyond this particular 3 sigma rule. So firstly, I have imported all these libraries: NumPy, Matplotlib. Statistics is one of the libraries that we do statistical related things, and we have pandas. As I'm using Google Colab, so I have mounted my Google Drive. So I'm going to give access to my Google Drive so that I can read this file from my Google Drive itself. But just in case you don't want to do this, you can just click on files, upload this particular file, and you are good to go. So the drive has been mounted, and that's how my data looks like, right? So if I just do data.head, that's how my data looks like. I have data sold, postcode, price, property type, bedrooms. What is the type of data? It's quite evident. It is a data frame because it is used from pd.readcsv. Now this is the function that we have created, function to detect outlier on one-dimensional data sets. If you look at this particular function, it's very easy to understand. I have defined the function name as find anomalies. I am expecting some data here. I have created a null list, an empty list. First of all, I'm calculating the standard deviation. Second of all, I'm calculating the mean using the statistics library, and I'm storing the standard deviation and mean. Very simple. So what's happening here is I have the data and I'm calculating the standard deviation, which is my sigma, and my mean, which is my mu. Next is I have defined anomaly cutoff equal to standard deviation into 3. So I have defined a variable called as anomaly cutoff, which is standard deviation into 3, which is simply 3 sigma. You can see I have defined my lower limit equals to random data mean minus anomaly cutoff. So my lower limit is mean minus 3 sigma. My upper limit cutoff is mu plus 3 sigma. This is pretty clear. This part is basically mu minus 3 sigma, and this is your mu plus 3 sigma, right? So the logic that we are going to apply here is anything that is greater than mu plus 3 sigma or anything that is less than mu minus 3 sigma are basically your outliers. So you can see I'm running a loop over the data for outlier in data. If outlier is greater than upper limit or outlier is lesser than the lower limit, I'm appending this particular data set to anomalies. So let's say I have a data set of 10 records, 10, 20, 50 and 120. Let's say 4 records. So what's happening here is for each element, I have calculated the mean, I have calculated the standard deviation. Anything that is greater than this or anything that is less than this. For example, let's say this one. This value kind of follows this if block. It is successful. So in the anomalies, this particular data point will be appended. And if you return anomalies, you will get something like this, that this is an anomaly. Okay. So we'll try to quickly run this function, and we are going to run this function using I'm going to pass this price data. So I'm calling list1 equals to find anomalies data of price. If I run this, you can see there are 461 outliers. What is the total length of data? It is 29,580. Now if you start calculating 461 divided by 29580 into 100, which is almost 1.55%. 1.55% of the data are beyond the range of plus minus 3 sigma. And we know that in the case the data is fully normally distributed, it has to be 0.3% data. So this clearly means that the data is not normally distributed. So that's why I'm going to use some skewness function or kurtosis function to see whether the data is skewed or not. So you can see my skew value is 4.31, which clearly means that the data is positively skewed. And if you want to plot your data, for that I have imported the Seaborn library. I'm plotting the KD plot, and you can see it is quite evident that it is skewed, right? Your normal distribution is like this, but in this case it is like this. It is something like this, which clearly means it is not normally distributed. Now let's say I want to do some transformation. So I have converted the data into a logarithmic scale. Once I do this, I again run the skewness score. It is somehow closer to 0. Not exactly 0, but at least less than the previous skewness value. Which means the newly transformed data is somehow in a better shape as compared to the original data. Now if I run again the anomalies for the newly created data, you will see that the total number of failures are, or the outliers are 266. Now what is the percentage? 266 divided by 29580 into 100 is 0.9%. Better 0.9%. So coming closer towards the normal distribution graph. And if you plot the transform data, and you can see the transform data looks like this, and it pretty much is not normally distributed, but somehow it looks closer to it. Again, let's say I want to do a double transformation. I'm going to do a double logarithmic transformation by again converting the transform data into numpy.log, and now my skewness score is even less, 0.33. I will again run anomalies, find anomalies on this newly transformed data, and you can see 251 records. Now what is the percentage? 251 divided by 29580 into 100, almost 0.8%. So again further reduction in the data, and it is somewhat closer to normal distribution. So anything below 40 or above 80 are considered as outliers somehow. The second technique is going to be box plots. Now box plot is a visual way of understanding the data. It's a visual way of identifying the outliers. Similar to box plots, you can also use scatter plots. You can also do histograms. But again, box plots are better as compared to other type of visual analytics. So here I'm importing the Seaborn library and Matplotlib library. I'm just plotting the data for all the columns, and you can see for price, I can see a lot of outliers. As you can see, it considers everything above 75 or below 35 to be an outlier. The results are very close to method 1 above. So that's how my data frame looks like, and I'm just going to do the describe method for the price transformed and the double transformed. You can see that The third quartile is almost 2.6. The maximum is almost 2.75. So there are pretty much good amount of outliers here. But I'm just visualizing it and I'm able to spot that there are some outliers in the box plots. Interquartile range. Interquartile range basically is nothing but Q3 minus Q1. So Q3 is your third quartile and Q1 is your first quartile. In this example, you can see it's a list of multiple numbers. The length of this list is 25. The maximum of this list is 99. Okay, which is two values. I think, yeah, there are two values. And the minimum is 43. So using the statistics mean, I'm getting the mean value is 76.96. Okay. If you sort the list, that's how my list looks like in a sorted manner. To find the 90th percentile for these data, the ordered scores, start by multiplying 90% times the total number of scores, which gives 90% into multiplied with 25, which is 0.9 into 25, which is 22.5. The index. If you round up the index, it is 23. So what is my 23rd element? Hence 98, which is this 23rd element, is the 90th percentile for this data set. Now say you want to find the 20th percentile. Start by taking 0.2 into 25. So there are 25 elements. So I will do 0.2 into 25, which is 5, the index. This is a whole number which tells you the 20th percentile is the average of the 5th and 6th values in the ordered data set. So 20th percentile is 62 plus 66 by 2, which is 64. The median, the 50th percentile for the test score is the 13th score, which is 77. So these are some different techniques to identify outliers. Starting with the standard deviation technique, which is the most important technique because that's one of those techniques that is most reliable. We usually go for the 3 sigma technique to identify outliers. Apart from these, there are multiple other outlier algorithms, outlier detection algorithms, which we will go through in the predictive analytics part, where we will talk about luminol algorithm, which is outlier algorithm specially created for outliers. We'll try to go through that, but for the time being, I hope you had an understanding on how to identify outliers using the Python code. That's all about this particular video. See you in the next video. Till then, bye. The next type of issue that we are going to talk about when it comes to the data cleaning part is handling invalid values. Now, while dealing with data, there could be multiple scenarios where you would get some invalid values. For example, you are dealing with a column, a date column, and you are expecting it to be in a certain format, maybe YYYY format, but it is in a different format, or it is in text, or it is in something else, or it is an epoch date, something like that. Or else you are expecting one of the columns and one of these columns are having a lot of special characters. There could be column where it is not having logical values. For example, a logical value of a person's age could be between 0 to 100. What if somebody has minus 20? Now that could be an issue while the data collection part. There could be a data collection issue because of which you are having minus 20 or minus 40. If you see such scenarios, you have to deal with it. You have to ignore them or treat it as a null value and deal with it. So there are multiple scenarios when it comes to invalid values. Encode Unicode properly. In case the data is being read as junk characters, try to change encoding technique. Now, this is a common mistake that we usually face when it comes to encoding and decoding. Sometimes when we are reading the data set, using pandas.read CSV, sometimes the data set itself is encoded in a different Unicode technique. So you have to change the Unicode technique so that you are able to read the file. Else it will throw you error, Unicode error. Convert incorrect data types. Correct the incorrect data types to the correct data types for ease of analysis. Example, if numerical values are stored as strings, it would not be possible to calculate metrics such as mean, median, right? Very common problem. Sometimes our numerical values are also stored as strings. Some of the common data type corrections are string to number, this to this, where you have a comma, 12,300. You want to convert it into a number. String to date, this to this. Number to string, pin code this to this. So there could be multiple scenarios where your data is not in the expected data type format and you have to change it. Correct the values that go beyond range. As I was talking about, in certain scenarios, your values in that column could be some values which makes no sense. For example, temperature less than minus 273 degrees Celsius does not exist. But if you get it, what will you do? Right? You have to deal with it. Correct the wrong structure. Values that don't follow a defined structure can be removed. Example, in a data set containing pin codes of Indian cities, a pin code of 12 digits would be an invalid value. Right? Pin codes of Indian cities are always in the format of 6 digits. Right? So if you are considering 12 digits, it could be an error. Now talking about Hong Kong. Let's say Hong Kong does not have a pin code. What if you have a column called as pin code with some random values? Or else in Japan or else in Malaysia, you have you have a concept of pin code, right? In that case, if your pin code is completely different, you are expecting 8 digits, but you are getting 12 or 15 digits, which is completely wrong, right? So there are so many scenarios, so many instances where we have to deal with this. There is no practical applications like practical code for this particular slide so that I can help you out in different scenarios, but this is all about experience. Once you jump into the field of data analysis, once you start doing the EDA part, you will come across so many scenarios where you have to deal with it, and automatically you will learn by experience. That's all about this particular video. In the next video we shall be talking about various other topics related to types of data and various other types of analysis. Hi, in this video we shall be talking about the different types of data. Now this is something that we already discussed in the past. Majorly there are two types of data. One of them being qualitative data and one of them being quantitative data. Qualitative data simply are the categorical data and quantitative data are your numerical data. A variable which is able to describe the quality of the population are called as qualitative, and the variable which quantifies the population are your quantitative data. Under categorical data or under qualitative data, there are further two types, one of them being nominal and one of them being ordinal. Nominal data simply is the type of data that is not in any order. For example, gender, male or female, location, Japan, India, Indonesia, or Korea, or any other country. So these are your nominal categorical data. Ordinal are those kind of data that is in an order. Now, for example, economic status, low, medium, or high, grades, A, B, or C, and so on. They are in an order. You go from left to right or right to left, they are in an order, either in ascending order or descending order. Coming on to the quantitative part, quantitative is of two types, one of them being discrete and one of them being continuous. Discrete Numerical data are those kind of data that are discrete in nature. For example, if somebody asks you how many students do we have in a class, your answer has to be 42 or 45 or 50. It cannot be 42.5. There cannot be 42.5 students in a class or 42.7 students in a class. Not possible. So these type of data are discrete data. Continuous data are continuous in nature. For example, temperature range. What is the temperature in your country right now or in your place right now? 37.7 degrees or 37.2 degrees. So it could literally be any number within a range of something to something. So these are the different types of data. The reason why we talked about this topic is that from the next slide onwards, we will be jumping into each one of these type of data, categorical and numerical, and we will be performing some categorical and numerical analysis. That's all about this particular video. See you in the next video. Bye. In this video, we shall be talking about the different types of analysis that we perform. We all know that data are of two types, categorical, numerical, and based on the type of data, we should decide which type of analysis we need to do. Because our ultimate goal is to understand the data and understand the various characteristics. Now, the first topic is going to be univariate analysis. Univariate analysis is basically one type of analysis where we only deal with one variable. Uni basically means one variable. Now, what do you mean by univariate analysis? Univariate analysis is the simplest form of analyzing data. Uni means one. So in other words, your data has only one variable. Now, taking an example, I will try to explain this univariate analysis. Univariate analysis can be done for numerical and can be done for categorical data. But we mostly use it for categorical data because it gives us more insights. In terms of numerical data, we just get to know what are the summary statistics of this numerical column. Now we'll start with categorical data. So we will take an example of one type of data that we have. Let's say you are analyzing customers' data. Now this data is a churn records, which basically means that you as a data analyst have joined a company. Let's say the company's name could be anything. I will give a generic name. Vodafone is a global telecom provider. So let's say you have started using Vodafone. You join this company as a data analyst. Your manager gives you a data that, hey, you know what? These are all the customer related information. Our company's churn rate is almost 25%, which means almost 25% of the people leave our company on a monthly basis. Why people leave companies? They leave Vodafone or they leave In this video, we shall be talking about the types of analysis. Now, before getting into the types of analysis, first of all, we need to understand what type of data we are analyzing. We all know data is majorly of two types. One is categorical data and one is numerical data. Once we know our data properly, we know what are our categorical data and what are our numerical data. Further, we can take our next steps in analyzing the data. So the first topic that we are going to discuss is going to be univariate analysis. In simple terms, uni means one, variate means variable. So when you are analyzing just one variable, that is called as a univariate analysis. It is the simplest form of analyzing data. Uni means one. So in other words, your data has only one variable. Univariate analysis can be applicable for numerical data and can be applicable for categorical data. In numerical data, let's say we are analyzing a column age. What are the insights that we could get? Once we print the summary statistics of this column or probably plot a box plot, we will have a better understanding about its statistical values. What is the minimum age? What is the maximum age? What is the median age? What is the 25th percentile, 75th percentile, and so on. So this will basically tell us how our data spread is for a particular numerical column. Similarly, with the categorical column, we also get to know the distribution. For example, I have a column called as gender. And if somebody asks you, can you do the univariate analysis of gender? It simply means you need to analyze and understand what is the distribution of this particular column. Let's say the distribution is something like this. There are 8,000 male and 2,000 females, which clearly indicates that male are larger in number and the ratio is almost 4:1. So this is the simplest form of analysis, which is univariate analysis. So if you are dealing with a numerical column, you get the statistical information and get to know how the spread of the data is. And if it is a categorical column, then you get to know how the distribution of the data is. Now, let's try to take an example and understand more. Imagine I will be taking a telecom related use case, telecom churn analysis. This is my use case. So, for example, I'll consider a company, let's say XYZ, or just I'll give a name. Let's say you join this company called as Vodafone as a data analyst. Now, your manager tells you that, hey, you know what? We have a set of data which is having data for the past 24 months, almost 2 years. My data is telling that almost 25% is my churn rate. What do you mean by churn? Churn basically means when somebody leaves a particular company and join other company. With the context of telecom, churn basically means if a user who was a Vodafone user has switched to another network, and that switch could be because of multiple reasons. If the customer was not happy with the services or Vodafone was charging more, there could be multiple reasons because of which customers churn and join another company. For example, churning with context with banking. Let's say today you are using one bank, let's say HSBC. Tomorrow you get a better deal from Standard Chartered, so you probably start using Standard Chartered bank services because they are giving you better returns, better rates in your fixed deposits, better rates in your normal deposits in the bank. So probably you will leave HSBC and start using Standard Chartered, which means you are churning out from HSBC. So it is a loss to the HSBC company. So in this particular example, if a user is leaving Vodafone and joining another telecom company, that means it is a loss to the Vodafone company. Your task as a data analyst is to understand the data and come up with some insights. What could be the potential reasons why people are churning and what are the characteristics of people that are churning, right? And your ultimate goal is to understand the pattern. So imagine you have a data set of 1000 records, simply 1000 customers you have, and the churn rate is almost 25%, which is 750 is to 250. That means 250 churners and 750 active people. And there are multiple columns here: age, gender, location, and so on. As you are dealing with univariate analysis, what you do is you start analyzing columns one by one. So let's say I start analyzing my gender column. So what will be done as part of my univariate analysis? I will first try to analyze the overall customers. Just imagine there are 510 male and 490 female, which clearly means that female and male ratio are almost 1:1. The next step is to analyze the people that have churned. So let's say you see a similar trend, almost 125 male and almost 125 female have churned, which also means a similar ratio of churn with respect to male and female. So the insight here will be gender has not much of impact on churning. But what if for the churned customers you see a trend like this? Almost 180 male and almost 70 female, which means more than 2.5:1 ratio. So a lot of people who are male have churned. So that will go as an insight that male customers are more likely to churn. The reasons are unknown, but this is what the insight that you are getting from univariate analysis. Similarly, if you talk about any other categorical column, let's say location, you will do the same thing. You first start analyzing with the original data and then start analyzing with the churn data. And then you compare the percentage of the distribution of the data in the original data and in the churn data, and then you will start capturing the insights. In a similar fashion, you also analyze your numerical columns. Let's say you talk about age. In your original data, your mean age is 25. Your maximum age is 92. In the churn data, the mean age is around 35 and the maximum age is 92. And in the unchurned data, that means the active customers, the mean age is 23 and the maximum age is 56, which clearly means that people who are having more age or who are into the seniority level, they are the high churners. Now we are not talking about the reasons, we are just talking about the insights that we are getting from each type of analysis. Theoretically, that's all about univariate analysis. In the next video, we shall be talking about bivariate and numerical analysis. And once we are done with the theoretical concepts, we will jump into the practicals to show you how each of these analysis is done using a public data set. The next thing that we are going to discuss is bivariate analysis. The concept here remains the same. Similar to uni, bi means two and variate means variables. So when we start analyzing two variables, that we call it as a bivariate analysis. So a data which has two variables, you often want to measure the relationship that exists between these two categorical variables. Bivariate analysis can also be performed with numerical values or a combination of numerical and categorical. So in short, bivariate analysis can be done both for numerical and categorical values. We will take the same churn analysis example, telco churn analysis, and we will try to understand. Now before getting into the use case, let me just quickly explain you the basics. Let's say you are analyzing two numerical attributes or two numerical columns. That means you are analyzing two variables. Let's say age and salary. When you are analyzing two numerical attributes, the best way to visualize is using a scatter plot. Let's say age in my x-axis and salary in my y-axis. And you start plotting the graph and you see a graph like this. Using this graph, you can also interpret that there is a positive covariance and a positive correlation. As you can see, the trend is increasing. That means when the age is increasing, the salary is also increasing. And vice versa, when the age is decreasing, the salary is also decreasing. If you see a graph like this, it could potentially say you that when the age is increasing, the salary is decreasing, which means a negative correlation. And when you see a graph like this, where your data points are randomly distributed, it is very difficult to understand the numerical relationship between these two numerical variables. So we can assume that there is no correlation, zero correlation. And we all know what is correlation, what is covariance. We usually use correlation to understand the relationship between two numerical attributes. Correlation ranges from +1 to -1, where the values closer to -1 means negative correlation, which is this scenario. A value closer to 1 is positive correlation, which is this scenario. And a value near to 0 means no correlation, which is this graph. Similarly, if you start analyzing two categorical features, let's say gender and location. And just imagine I have two locations, just for the ease of understanding. I have two locations, let's say Japan and Malaysia. And gender, I have male and female. So I first start analyzing my numerical attributes, my categorical values for the original data. Let's say for male and female, Japan, Malaysia, Japan, Malaysia. That means most of the people are from Japan and less people from Malaysia. Same graph I will do for the churned customers, male, female, Japan, Malaysia, Japan, Malaysia. Now, if you see a graph like this, it is quite evident that the females who are staying in Malaysia are more likely to churn. Why? We don't know, but this is what my insight is telling me. And a similar technique has to be done for a combination of numerical and categorical. Let's say you are analyzing age and gender. You first analyze on the original data. Let's say for male customers, how does my box plot looks like? For female customers, how does my box plot looks like? And same you do for the churn customers, and you identify the difference. You can also make use of some different other type of charts to understand. But the concept remains the same, that bivariate analysis is done with two variables. It could be two numerical, two categorical, or a combination of numerical and categorical analysis. That's all about bivariate analysis. In the next video, we shall be talking more about numerical analysis and what could be done in the numerical analysis part. The next thing that I'm going to discuss is multivariate analysis. Again, the concept here remains the same. The more deep dive you are trying to do with your data, the more features you analyze, the more insights you get. So multi means multiple and variate means variable. Let's say you are analyzing 4 columns, 4 categorical columns. Obviously, the graph will be very complex to understand. The analysis itself will be very complex. But you could end up getting more insights when you go into the multivariate area. Hence, EDA is performed based on your requirements. If you have a specific given time to finish EDA and get insights, you could probably skip multivariate analysis. But if you have enough time for your analysis process, you can jump from univariate, bivariate to multivariate. So 3 variable, 4 variable, and the more variables you analyze, it becomes more and more complex, but it will be fruitful. So in simple terms, multivariate analysis is kind of analysis where more than 2 variables are involved. Again, this could be a combination of categorical, numerical, only categorical, or only numerical attributes. In this video, we shall be focusing on the numerical analysis part. We all covered bivariate, univariate and multivariate. Somehow numerical analysis was already covered there, but let's try to discuss what extra do we do when it comes to the numerical data. We also perform various analysis over numerical data. For example, dealing with a single numerical variable, we might be interested in knowing the statistical information such as mean, median, 25th percentile, 75th percentile, minimum, maximum, etc. And when you are dealing with more variables, you might be interested in knowing how these variables are related to each other, whether they are positively correlated, negatively correlated, or they are not correlated. So when it comes to numerical data analysis, we also perform multiple types of analysis. One could be a box plot symbolizing a single variable analysis where you are analyzing just one single numerical attribute. When you are analyzing multiple numerical attributes, you could use a scatter plot to understand the correlation between these variables. There is another thing that we also do, which is again finding the correlation. But imagine you have a data set where there are hundreds of numerical columns. Is it feasible to plot scatter plots for each and every combination of numerical attributes? Let's say numerical attribute 1 with 2, you plot one graph. 1 with 3, 1 with 4, 1 with 5, 1 with 6. Imagine how many scatter plots you will end up. So instead of doing scatter plots for each and every numerical attribute with each other, a better way of handling this kind of data will be using the CORR function, which is a part of Pandas data frames. When you are using the data, you can simply call the correlation function and you can plot it using a heat map. When you plot it using a heat map, you will end up getting a graph like this, which is your 100 variable cross 100 variable map. Variable 1, variable 2, dot dot dot, variable 100. Variable 1, variable 2, dot dot dot, variable 100. And this heat map will tell you or will give you an idea of which variables are having positive or negative correlation with each other. Let's say this is a grid, this is a matrix like this. Now imagine this box is having some dark color, which potentially means from the scale that you identified that this is having a positive correlation. So you can easily spot that variable 1 and variable 2 are positively correlated. Let's say this particular value is very light shade, somewhere close to -1, which clearly means that variable 50 and variable 2 are negatively correlated. So using the grid, using the color grid, you will be able to identify correlation between multiple numerical attributes. Apart from this, we also perform multiple other types of numerical analysis, which includes kernel density estimation plots, histogram plots, and multiple other plots. So once we jump into the practicals, I will show you using a demo data on how do we perform different types of analysis. Let's jump into the coding part to understand more about how to perform different types of analysis, be it univariate, bivariate, or numerical analysis. So for this particular exercise, I'm going to import all the required libraries, and then I have already uploaded the same churnmodeling.csv file. So I'm going to fetch that using the pandas.readcsv. How does my dataset looks like? That's how my dataset looks like. I have columns like row number, customer ID, surname, credit score, blah blah blah, and there is a column called as exited, which basically tells whether the customer has left the company or is still in the company. 1 means this customer has exited, he or she is a churned customer, and 0 means they are still active. Your target as part of EDA is to understand what is the characteristics of the people that have churned and probably why. But in this particular exercise, we will be majorly focusing on the different types of analysis using Python. Once we cover this, once we jump into the actual EDA case study where we will be taking the exact same data set, I will be explaining you the entire analysis activities starting from step number 1 till the end, and I will also show you how insights are fetched. So in this particular video, we will just be focusing on the univariate, bivariate and the numerical analysis. So firstly, I will only take some of these categorical columns and I will create a new data frame. So telco new equals to telco base data, and then I will just choose geography and gender and exited column. Done. If you want to see how your telco new looks like, it looks like this. Okay. So firstly, I will be starting with a count plot. I will be using a count plot, which is a Seaborn count plot. I'll be using this. What is a count plot? Shows the counts of observation in each categorical bin using bars. It's up to you how you want to visualize it. You can use a simple bar chart. You can use any library's bar chart. In my case, I'm just using a count plot. So what I will do here is I will write a for loop for I predictor in. I'll probably explain this code after writing it. Columns equals to, let's say I want to just skip my exited column, and then plt dot figure and then cbon.count plot. Here I will pass my data. What is my data? Telco new, x equals to predictor, which is what I am passing here, and there will be a hue of exited. You can see in my data telco new, I have 3 columns. So here I'm dropping exited column and I'm only taking these 2 columns. So I'll be running through a loop over these 2 columns, and I will be plotting the count plot of the telco data where x is my predictor. Let's say first time the predictor will be geography and the second time my predictor will be gender. And I'm using a hue for exited. So if you run this, you will be getting 2 graphs because there are 2 columns. One is geography and one is gender. Now what do you interpret from this particular graph, the geography graph? You can see for France, people who have left are around 800. See, you can also plot the labels in case you want to have a further analysis. I'm just visually taking some inputs. Let's say the churned customers are somewhere around 800 and the non-churned are somewhere around 4200, right? So what is the ratio of churned? 800 by 5000, almost into 100, which is 800 into 100 divided by 5000, which is around 16%. But in the case of Germany, you can see how many churned customers? Again, around 800 or 900. How many not churned? Around 1700 or something. So what is the ratio here? 800 divided by 2500 into 100. Sorry, my bad. 800 divided by 2500 into 100, which is almost 32%. What is my original churn ratio? Let's try to check that. So let's say telco new dot exited dot value counts. If you do this, you will be getting this ratio, which is 8000 is to 2000. So I assume the churn ratio is almost 20%. If you want to get the exact ratio, exact percentage, divide it by the total length of telco, and then multiply it with 100. You will see that almost 20% is your churn rate. But in the case of Germany, the churn rate is high. So from this univariate analysis, I am getting an insight that people staying in Germany are more likely to churn. You can do the same for Spain also. Univariate analysis without doing the graphical thing, you can also simply do dot value counts, and you can also try to get the insights. But visual analytics is more intuitive, right? It gives you more insights. It helps you understand better as compared to just numbers. Similarly, from the second graph, I would say female are more churners as compared to male. You can see the total number of people in male are high, but the churners are more in female. So one insight here is female are more churners. So the second insight that we got is people staying in Germany are more churners. These are the two insights that I got from my simple univariate analysis. So in your case, you have a data of 100 variables. You have to simply go through each and every graph and you have to interpret. Sometimes you would get insights, sometimes you won't get insights. But if you don't get insights, that does not mean that this particular column is not important. Just imagine, for example, you get that for gender, the ratio is almost same. In the original data also, it is in the same ratio, and in the churn data also, it is in the same ratio. Does that mean gender is not important? No. That means gender alone is not important. Gender combined with any other feature could be an important insight, could be an important feature, right? So sometimes your univariate analysis might not give you those much of information. So you should always go ahead and do bivariate, trivariate, multivariate and other analysis. Jumping on to we already performed univariate analysis, which is this piece of code. So I'll just take this code above here. So this is my univariate analysis. Done. Now talking about the bivariate analysis. So in case of bivariate analysis, I'll again use another type of plot. The reason behind using another type of plot is you will be introduced to these kind of plots as well. So which is a win-win situation. So I'm going to use Seaborn hist plot. Okay. What do you mean by a hist plot? Plot univariate or bivariate histograms to show distributions of the data. So in this case, let's say I will just simply plot hist plot. X equals to gender, Y equals to geography. No, I don't need Y. So I will just use hue as geography. And then what is my data? My data is telco new, stat equals to count. That's it. Okay, let's also use the multiple feature. Approach to solving multiple elements when semantic mapping creates subsets. Only relevant with univariate data, but yeah, we can use a multiple also. Multiple equals to touch. You don't have to memorize all these codes, as I told you before also. When it comes to Python part in the data analysis or data science areas, nobody will ask you about writing codes. Can you write down a code for hist plots? No. You can definitely take help of the web to plot down anything. So in this case, you can see obviously the graph might not look that good, but it is quite evident that for female customers, you can see France, Spain and Germany. For male customers, France, Spain and Germany, right? You can also do the same thing for your churned customers and you can also get some insights. Let's say will create a new data frame only for the churned customers. Let's try to do that. So I will create a new df. Let's say I will just do telco new of target 1, which is telco new dot lock of telco new of exited equals to 0 equals to 1, my bad. So these are all my churned customers, right? So I'm only selecting exited equals to 1 and these are my churned customers. Same thing, I will just copy paste here. I will change my data frame. That's it. Everything remains the same. Now you can see that this is the graph for the churned customers. So let's try to snipe it out and then we will analyze this on paintbrush. So that's my churn customers and that's my original data. That's my original data. Now what do you infer from this? In the original data, you can see, if I just look at the data, so first of all, you have to identify the ratio. Let's say female, there are 2250 France, almost let's say 1100 Spain and around 1200 Germany. What is the ratio here? Maybe around 450 France, around 220 Spain, and Germany is very high, almost 430 Germany. You can see out of 1200, 430 people who are from Germany. So what is the ratio? The ratio is almost 430 divided by 1200 into 100, which is almost 36%. So female plus Germany. So female customers staying in Germany, 36%. What about male in Germany? Around 380. And what is here? Around 1300. So what is the ratio? 380 around 1300 into 100. So even for the males also in Germany, the ratio is almost high. The churn rate is high, but this is an insight. Using univariate analysis, what we got is people staying in Germany are more churners. But now we are getting that female who are staying in Germany are more churners as compared to male. Male are also churners, but the female ratio is pretty high. That's one of the insights that we got, right? Moving on to other types of analysis. So we will be considering some numerical analysis. In numerical analysis, first of all, you can plot box plots, you can plot any kind of plots. We will get started with the correlation plot, okay? As I told you, first thing is correlation. What is correlation? It ranges from -1 to +1. That we all know, right? +1 or near to that, positive correlation. -1 or near to that is negative correlation. And anything near to 0 is no correlation. That we already know, right? So what we will do is we will quickly plot the correlation function here. You can see when I'm plotting the correlation, you are able to see a matrix, right? In your columns and in your rows, the names are same. So using this matrix, you can also identify which of them are highly correlated or which of them are negatively correlated. As you can see, this one -0.3 or this one same -0.3. That means number of products and balance are negatively correlated. Do we see a very high positive number? I think the highest positive number that I can see right now is this. Exited with respect to age. That means age and exited are more correlated. That means higher the age, possibility of getting more exited. That means people who are into the seniority level are exiting more. Now, how do we beautify this using some graphs? So what we will do is plt.figure. I will just use a fig size, let's say 20 cross 8, and here I will do telco based data dot correlation. I want to have a correlation with respect to exited, because that is my y variable. Our main focus is to understand the correlation of different features with respect to the exited column, right? And then I will sort the values with respect to ascending equals to false, and then plot it using a bar chart. Okay, so you can see this is how my correlation function looks like, correlation output looks like with respect to exited. I'm not doing correlation of each column with respect to each column. This is specially the correlation between multiple columns with respect to exited. And you can see the first one is ignorable, because exited with respect to exited, obviously the correlation will be 1. So ignore this thing. You can see age is a factor. So we are able to see age is an important factor. Balance is also an important factor. They are having positive correlation. And rest, all of them are very small values, so I will not consider. And you can see number of products and is the active member are negatively correlated. So somehow these 4 features are very important with respect to exited. So this is what my insight we are getting from here. Next step is I will simply plot my correlation function, which we did right now, which was this. We will plot this correlation function using a heat map. So I will use the same concept, plt.figure, fig size equals to 20 cross 12 cross 12, because it's a square. Seaborn.heatmap, you can see Seaborn heat map. It's a plot a rectangular data as a color encoded matrix. And if you scroll down, you will see some graphs like this. This is a heat map. Column with respect to column. Okay. And you can see on the right hand side, you will see a scale. That means the lower the number, the darker it is, and the higher the number, lighter it is. So you can easily spot where you have lighter values and where you have the darker values, right? So we will be using the same concept, heat map of telco based data dot correlation. There is a function called as CMap. Okay, if you go and check CMap, there is a function. Which type of CMap you want to use? Crest CMap will give something like this. Cube helix will give something like this. So you can use cube helix or crest, whatever you want to. I will simply use a paired one. Paired. There are multiple options. So I will be using paired. And this is how my graph looks like. I will just make it little bit small so that it fits my screen. And you can see, again, I will make it even smaller. It is still not visible properly. And you can see this is my graph. How do we interpret this graph? Let's say sky blue is negative correlation. Easily identifiable, right? Number of products and balance are negatively correlated. Anything into this box, nothing. Anything into yellow, nothing. Anything into purple, nothing. Nothing. Orangey, nothing. Red, yeah, red. Age with respect to exited, high correlation. And these green ones are very low positive correlation, or you can say no correlation. So this is giving me an insight that age is an important factor, and even number of products with respect to balance, right? So that's how you plot your heat map. We will also try to cover some other plots so that we can also analyze few other numerical attributes. Now the simplest thing that we can do is we have this data frame, base data. No, not base data. Yeah, we have base data. So let's say age. Let's say I want to analyze age. We all know age is a numerical column, right? It has values ranging from something to something. If you sort it out, you will be able to get it. If you want to plot age, will you be able to plot using a bar chart? A bar chart will be very clumsy because it could range from 18 till 92 or 95. It could have a lot of bars which will make it look very clumsy. A better way of analyzing it will be using a line chart, or if you convert it into age bins, probably you will be able to visualize the bins, 3 to 4 bins. So converting it into bins will be taught in the next class, where we will teach you the derived metrics, but without converting into bins, let's try to plot it using a line chart. So telco base data of age, and then I will do value counts, and then I will sort the index because my index here is, let me go line by line. So when I'm doing dot value counts, you can see for each age I'm getting the total number of values. What is my index? My age is my index. So I will sort my index. How? Ascending equals to true. Once that is done, if you plot it, if you just print it, the lowest age is at first and the highest age is at end, and then simply do plot. If you plot, by default it will be plotting you a line chart, which basically tells you that most of the people, average people, are ranging around this age. Let's try to do the same activity for the churn customers. So I will exactly do the same thing what we did earlier. I will create another data frame, telco base data for 1. Telco base data, telco base data. Done. And then I will copy paste this code, and this is for only for the exited customers. I will change it to this. That's it, and plot it. Now you can see if I take this graph to and probably this one. Now this is your original data and this is your churn data. You can see in the churn data, most of the people are around this range, which is around 40 to 55. But in the original data, most of the people are in this range, around 28 or 27 to 47 or 48. That means people who are churning, age is an important factor. People who are churning, they are more in age. They are some senior people. And you can see beyond this line, the graph has almost dead. But here, during 60 to 70, you can see good amount of spike, right? So age is an important factor, and we are able to get that from this graph also, right? Similarly, we will also plot some other graphs. There is Seaborn KD plot, which is kernel density estimation plot. It is used to visualize the distribution of observations in a dataset, analogous to a histogram. KD represents the data using a continuous probability density curve. So we'll try to use this. So let's say I will define KD plot telco base data. Let's say I will analyze my age. Okay, age telco base data exited equals to 0. Let's say I want to have a color as red for my exited people. Shade equals to true. Okay, and then simply I will copy paste this where exited equals to 1, and I will change the color to blue, and then I will simply do dot legend. Let's say the first legend will be no churn and the second one will be churn. And then this is the density function, because kernel density set x label is basically your age, and then I will set a title which is age by churn. Dot legend, yeah, looks fine. This one, yeah, this one. So now I'll run this code, and you can see a graph will be shown where both churned customers and not churned customers are shown. The active customers are your red customers and inactive are your blue ones. So if I take it to my this thing and explain here, it is quite evident that people who are not churning, they are maximum having in this range. The age is low. People who are churning, the highest distribution is around this range, which is quite evident that age is an important factor. Similarly, you can also use this same piece of code in analyzing other columns. Let's say there is a column called as tenure, 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 and tenure. Run this and you can see that this is your tenure graph. I don't see a huge impact with respect to tenure. Any other numerical columns that we have? Let's say we have a numerical column called as balance. Balance, 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 balance. So what does my balance tell? If I just use it, so here people who have not churned, they are mostly, the density is high here. People who have churned, the density is low. But when it comes to larger balance, people who have churned are having larger density, larger balance here and less. So somehow with less balance, there are less number of people who are churning, who are having less balance. People who are having more balance are more likely to churn because they have balance amount, right? That means that amount they have to pay to the company. Maybe because of that they are churning, so that they don't have to give that amount. Could be a reason. But this is overall giving you a understanding. So that's all about different types of analysis that we perform. In the next videos, we will be talking about derived metrics, and then we will be jumping into a case study. In the case study, we will be taking similar churn analysis use case. We will be performing each and everything from scratch, starting from data cleaning, data collection, analysis, and finding insights, which will be an end-to-end case study, which will give you more ideas on how to approach a problem. But this video was all about, understanding the categorical and numerical analysis using different type of plots. I hope you had good understanding from this particular session. That's all about this particular video. See you in the next video. The next topic that we are going to discuss is going to be derived metrics. As the name suggests, derived metrics are those kind of metrics that are derived. Derived metrics creates a new variable from the existing variable to get an insightful information from the data by analyzing the data. In simple terms, derived metrics are those kind of features or variables that we manually create using certain techniques. Imagine you have a data set and there are multiple, obviously there are multiple records and there are multiple features. Imagine there is a feature called as age, and the age is in this format 28, 20, 28, 29, blah blah blah. What if somebody asks you to create another feature like age in months? What we do here is we simply multiply the age with 12. That will give me the age in months, right? Now this feature is not present in your original data, but you have manually created it. So it could be a calculated from data feature. Some of the features we also create using domain knowledge. Imagine you have a column like x1 and you have a column like x2, and you know that if you combine both of them, probably you will find another column, and that could let's say it could be x3. Now that is something from the domain knowledge. For example, you have a column like sales and you have a column like profit, and you want to find the total expenditure. Now expenditure is not a part of the original data, but you are calculating using some mathematical formulas using your domain knowledge. Now that is a derived matrix. So we call it as from domain knowledge. At certain point of time, we also do binning. For example, we have a column like age 25, 29, 30, 61, 90, 18, dot dot dot. What if when you are analyzing the age, you are visualizing age and it could end up in a multiple bar charts, multiple bars, which is difficult to interpret. In that case, probably what you will do is you will convert it into bins. Let's say 0 to 20 is a bin, 21 to 40 and 40 plus. So you created 3 bins. So this becomes 21 to 40, this becomes 21 to 40, this becomes 21 to 40, this becomes 40 plus, this becomes 40 plus, this becomes 0 to 20 and so on. So this is simply your feature binning. And coming on to feature encoding, there are multiple encoding techniques. Especially in the field of predictive analytics or machine learning, your categorical data can be extremely useful. However, in its original form, it can be unrecognizable to most of the models, because ultimately we create models and models are run in computers, and computers don't understand categorical features. So in order to solve this problem, we can use different encoding techniques to make our categorical data legible. So there are multiple encoding techniques that we will understand in the future videos. There are techniques like label encoder, techniques like one hot encoder, dummy encoder, target encoder, hash encoder, and so on. So we have a separate session on feature encoding where we will be going through each and every encoding techniques theoretically and practically. But overall, that's all about your derived metrics. Simply, derived metrics are those kind of columns which are not present in your original data, and we have to manually create it based on our domain knowledge or based on our understanding or based on some other features. So that's all about derived metrics. In the next video, we shall be jumping into feature binning, feature encoding, and various other topics. Feature binning. As we discussed in a nutshell in the previous video, that feature binning is simply one of those techniques where we create bins out of a feature. Feature or variable are nothing but some of the columns from your data set. Feature binning simply converts or transforms continuous or numerical variable to categorical variable. It can also be used to identify missing values or outliers. There are two types of binning. One of them being unsupervised binning, which is equal width binning. That means you have a column and you divide them with equal width. And one of them is equal frequency binning. That means you divide it with equal frequency. That means each bin will have equal amount of data points. And in here, each bin will be divided equally. For an example, I have a data set and I have a column called as age. If you divide it with equal width, that means 0 to 12, 13 to 24, 25 to 36, you can see each bin is having 12 years of data, each bin. But with equal frequency basically means that each bin that will created, that will have equal frequency of data points. Let's say the first bin has 100 data points, 100 data points. In short, if you have 1000 data points, you divide it into 10 bins. So your labels or your bins will be created automatically based on the frequency. Which type of binning is preferred? It all depends. As we said, feature binning, feature encoding, all these kind of things we usually use for predictive analytics, which is a hit and trial process. So we have to create bins, perform our analysis, check our model's behavior, again come back. It's an iterative process. The second type of binning is a supervised binning, which is an entropy based binning. Unsupervised binning, it transforms continuous or numerical variable into categorical variable without taking dependent variable into consideration. Equal width separate the continuous variable to several categories having same range of width. Equal frequency separates the continuous variables into several categories having approximately same number of values. And supervised binning, it transforms continuous or numerical variable into categorical value, taking dependent variable into consideration. Now, what do you mean by dependent variable? If we are talking about a data set, now let's say you have a data set of multiple customers, and there is a column called as whether a customer has exited or not. And if your final goal is to create a predictive model that will be able to understand your customers' details, understand your customers' characteristics, and will be able to predict whether a customer will be exited or not. In that case, you are kind of predicting this exited column. So exited becomes your y variable, otherwise called as dependent variable. And all the other columns are called as your x variables, otherwise called as features, otherwise called as independent variables. So supervised binning is when you transform a continuous numerical variable taking dependent variable into consideration. That means if you are considering age, let's say the people's age are something like this, you also consider how the age is impacting the exited column that we are going to predict, and based on that you create bins. So this type of binning technology or technique is called as entropy based. Entropy based binning separate the continuous or numerical variable. Majority of values in a category belong to same level of class. Now supervised binning is not required if you are just analyzing some data without any y variables. Imagine you are working on a EDA use case and your data set need not have to be prepared for the predictive analytics part. Your only focus is to understand and get insights from the data. EDA is your final end goal, and your data set does not have a y variable like this. Simply, let's say you have customers data, that's it, and you are trying to analyze the customers data, which customers are similar to each other, kind of doing a customer segmentation use case where you are trying to create segments of customers who could be similar to each other. In these kind of use cases where you don't have y variable or dependent variable, in that case you cannot use entropy based technique. You always have to go for the unsupervised binning technique. So feature binning is very important when you are considering it to be, you are preparing your data for your predictive analytics. If you are only considering EDA or exploratory data analysis, feature binning might not be important. Only in certain cases it could be required when, let's say, you have a column like age, and when you are kind of visualizing it, now age could range from 0 to 90 or 100. If you visualize using a bar chart, it could be very clumsy. It could have 100 bars. Even when you analyze it using a line chart, then also you might not be able to get good insights from it. So in this case, what we do is we create bins so that visually we can have multiple bars and we can understand, oh, most of the people are within the range of 21 to 40, and then comes 61 plus. So it all depends scenario to scenario. If you are required to perform binning, then you can perform binning, else not. That's all about this session on feature binning. In the next session, we shall be helping you out in the Python part, in the practicals part, how to create bins using a sample dataset. So let's get started with the practicals part. In order to get started, I will upload my CSV file here. So my CSV file is uploaded. We will get started with importing the libraries. Import pandas as PD, import numpy as np, import matplotlib.pyplot. Well, we don't need matplotlib, but just in the case. And we will be using sklearn's library. So I am going to import pre-processing. So once this is done, let me just copy the path of this file, close it. df equals to pd.read csv content / churn modeling, and you can see my data is ready. That's my data frame. I have row number, customer ID, surname, all these features I have, and you can see there is a column called as exited. Okay, so exited basically means whether a customer is active or exited. 1 means exited, 0 means active. The first thing that we can do is, let's say I'll just click on info to check whether we have null values or not, and you can see evidently visible that gender has some null values. We will be using age for performing our binning task. Age or tenure, we can use any of them because both of them are your continuous numerical values. So the first thing I'm going to do is I'm going to drop some of these random columns which makes no sense in our analysis process. So it's a very good exercise to drop off columns that you don't need for your analysis, because unnecessarily they will be eating up your space and memory. So customer ID, row number, and surname. What else? We will delete it from axis 1. In place equals to true. In place equals to true basically means when you are performing this task, you don't need to assign the same thing to your data frame. Directly your data frame will be updated. df.drop columns equals to this, bracket close, axis, yeah, done. So okay, so my data frame is dropped, my 3 columns are dropped. In case you want to check your new data frame, that's how it looks like. My features that are not important, they are gone, right? Even though it makes no sense for this particular activity, but it's a good practice to do. So we will get started with the binning technique. So let's say I am going to use age. So what's my age? The minimum value is 18 and the maximum value is 92. Okay, so 18 till 92. Now let's say I am going to create some labels. Labels 0 to 20, 21 to 40, 41 to 60, and 60 plus or 61 plus, or above 61, simply above 61. Okay, and then I'm going to create my bins 0, 21. So basically bins has to be the first number from each of your labels: 21, 41, 61, and let's say the last number could be 100, which basically means any number beyond your maximum value. So let's give 100. So here I'm going to create my age bins age bins is equals to pd.cut. I'm going to pass my age, I'll pass my bins, I'll pass my labels equal to labels, include lowest equals to true. The moment I do this, my bins should be created. df.head 5. You can see that my age bins are created. You can compare. 42 falls under this category, which is true. This is some mistake. 41 falls under this category. This falls under this category. Why this one has not been into this category? That's going to be a problem. Okay, 41 is considered in it's considered in the second category. So let's just change it to 20, 60 and 100. Let me run this. Yeah, now it works. You can just cross check this thing. For age 42 it falls in this category, 41 to 60. This is 21 to 40 and so on. If you want to just check df of age and age bins, age bins, small b. So you can just cross check for all the items. In case you want to convert it into a CSV file and you want to check it, you can do that. To CSV and let's say test.csv. The moment you do this, your test.csv is created. Download it. As we are using Google Colab, we have to do this, or else if you are using Jupyter Notebook, your file will be created in your local system in the same folder itself. Now in this case, I will just quickly cross check. There is a null value. For null value, it has not imputed anything. So in order to do it for the null values also, if you are going to perform some feature binning activity, make sure you have already treated your null values before doing this step. Else you will have to impute your null values twice. So I'll cross check some of these entries. This is fine. So almost it has done a good job. So my bins are ready. So finally my bins are ready. Just in case I want to check my age bins value counts. That means how many records do we have for each bins. You can see most of the people are in this category. 6146 falling under this category. If you feel it's too much of people falling into one single category, you can further divide it into 21 to 30 and 31 to 40. So it all depends on your use case. Let's say we want to plot this particular bins. So I will quickly write a small code making the bar chart on the data. plt.bar, I will pass my labels, I will pass my age bins dot value counts. So basically I am asking my bar chart to take the labels as my x-axis and take the value counts as my y-axis, and then giving the title. So plt.title age count, and then giving x and y labels. That means on your chart, what do you want to write in the x-axis and in the y-axis? So plt.x label, I will give it as age bins and age bins. plt.y label age count, and then finally visualizing the plot, plt.show. Run this and you can see that that's how your graph looks like. Now this is quite easy to visualize as compared to your numerical attribute. Apart from this, if you want to add labels on top of your graphs, that is also possible. However, it's not a part of feature binning, but I'll just quickly show you how it works. Let's say I'll create one of my functions, add labels. I'll pass xy, and then for there are multiple ways to do this. I'm just choosing one of these ways. For I in the range of length of x, plt.text. I'm going to use plt.text I, y of I, y of I. Done. I will copy paste this code, and then I will call my add labels. Add labels, and then I will copy paste this thing. Run this, and you will be able to see the labels on top of the graph. So that's all about how do we perform feature binning. You can also do some other techniques to create bins. You can also use a simple for loop. In that case, you have to iterate through your entire data frame .age column. Wherever you see if age greater than equals to 60, then df of age bins equals to above 60. Else if age greater than equals to 41, then df of age bins equals to 41 to 60. So you can also write a for loop in order to accomplish this particular task. So there are multiple ways to do this, but that's all about feature binning. I hope you understood the concepts of feature binning. In the next video, we shall be jumping into the feature encoding part. Hi, in this session we shall be talking about feature encoding. Feature encoding is one of the techniques where we try to encode a feature. Feature encoding helps us to transform categorical data into numerical data. Now, what is the need of feature encoding? Let's try to understand that. As we all know, it all starts with business understanding, data cleaning, data preparation, and then EDA. After EDA, your next task has to be predictive model building, or simply machine learning model building. Predictive analytics or predictive model building is something that we are anyways going to cover in the next module. But let's try to understand the need of feature encoding. Computers don't understand categorical data, even though categorical data could have a lot of information within it. Lot of information is there in both categorical and numerical data. But ultimately, when you feed your data to a predictive model, your predictive model might not be able to understand categorical data. And hence, you have to end up converting a categorical data into numerical data. That conversion is basically called as feature encoding, where we convert or transform a categorical data into numerical data. The simplest form of encoding is label encoding. Let's say you have a column called as gender. You have F, M, F, and so on. The most idiotic approach to convert a categorical data to numerical data is to give them some numbers. For example, I give F number 1 and M number 2. So all my F becomes 1 and all my M becomes 2. So this type of technique is called as label encoding. Label encoding is a technique to transform categorical variables into numerical variables by assigning a numerical value to each of the categories. Let's say you have a column called as location. You have Hong Kong, Malaysia, India, Korea. You simply give them 1, 2, 3 and 4. Now the drawbacks of this particular encoding technique are many. The first drawback is if you assign such numbers, when you feed this data to computers only understand numbers. Now in that case, your predictive model could be biased towards these numbers. They will be treating this number to be more priority than this number. Similarly, in the case of gender, there could be a scenario where males could be treated in high priority as compared to females. In order to have an unbiased priority, so that models won't be biased on these numbers, label encoding should not be used for your X variables or simply your independent variables. So for example, if you are dealing with a use case, let's say you have data and you are simply doing the churn analysis prediction. That means you are going to predict whether a customer is going to churned or not churned. So you have a column like churn and you have other columns as well: age, gender, bandwidth, all those things. So it is not recommended to do label encoding on X variables. Label encoding can be done on Y variable, which is a dependent variable, right? But on X variables it is not recommended. We perform label encoding using a simple technique called as label encoder. Label encoder. All the encoding techniques are part of sklearn library, which we will be using in the practical part. But label encoder is something that we will be using to perform this label encoding. The second technique of feature encoding is one-hot encoding. This technique is used when independent variables are nominal. What do you mean by nominal? That means they are not in a specific order. Gender is a nominal data, location is a nominal data. It creates k different columns, each for a category, and replaces one column with the rest of the columns is 0. Here 0 represents the absence and 1 represents the presence of that category. So in simple terms, if I talk about a column called as location, let's say I have 10 customers, Hong Kong, who stays in Hong Kong, one stays in Malaysia, one stays in India. This person again stays in Hong Kong, Malaysia. Let's say I have 6 customers, 1, 2, 3, 4, 5, 6, out of which 2 people stay in Malaysia, 3 people stay in Hong Kong, and 1 in India. If we have to perform label encoding, this becomes 1, 2, 3, 1, 1, 2, which is not the right step, not the right technique. If we perform one-hot encoding, what happens is it creates 3 columns: location underscore HK, location underscore India, location underscore Malaysia. So wherever you see HK, this becomes 1, others become 0. Wherever you see Malaysia, others become 0, the Malaysia part becomes 1. For India, this becomes 1, others are 0. 1, 0, 0, 1, 0, 0, 0, 0, 1. And these are all your newly created features as part of the one-hot encoding technique. And we all know that binary is the most accepted format for computers, right? So one-hot encoding is one of the most preferred type of encoding technique. Apart from one-hot encoding, there is also another type of encoding which is not mentioned here, which is a very similar technique to one-hot encoding. The technique is called as dummy encoding. As part of one-hot encoding, the 3 features that we create are otherwise called as dummy features. And in this case, we have created 3 dummy features, but you can see that there is no need of one of them. Imagine you don't have this column. Now this column is a quite obvious column. Why? Because if this is 1, this is 0, obviously it has to be 0. 0, 0, it has to be 1. 0, 1, it has to be 0. 0, 1, 0, it has to be 0. So it's a quite obvious column to have. So in dummy encoding, we get rid of one of these columns and we end up having 2 columns. This is called as dummy encoding. You can remove this column, you can remove this column, you can remove this column. Any of these dummy features can be removed, but we just have to remove one of them. That's dummy encoding. Another type of encoding is target encoding. What do you mean by target encoding? In target encoding, we calculate the average of the dependent variable, that is my Y variable, for each category and replace the categorical variable with the mean value. It is another type of encoding technique. Similarly, we also have hash encoder, which represents categorical independent variable using the new dimensions. Inside hash encoder, there is a concept called as n components, which basically means how much newly created columns you want, how many hashed columns you want to create. The user can fix the number of dimensions after transformation using component argument, which is n components. If you define it as 8, which is a default value, what happens is, irrespective of whichever column you pass, it could be location, it could be gender, it could be anything, your hash encoder will create 8 new columns. The way it creates values is very difficult to understand because they are hashed values. But majorly these are the 4 types or 5 types of encoding techniques that we discussed. There could be multiple other techniques as well, which includes binary encoder and various other encoding techniques that we usually don't use. But if you ask me what is the most important one, I would say label encoding, which is used for your y variables, and one hot encoding or dummy encoding is one of those encoding techniques that we mostly use. So that's all about this particular session on feature encoding. In the next video, we shall be talking about the practicals part on how do we implement these kind of techniques using a sample dataset. It's time to jump into the feature encoding part, the practicals. First of all, I'll upload my dataset, which is the same churn modeling dataset. In the meanwhile, I'll start writing down my import statements. Pandas as pd, import numpy as np, import matplot, lib.pyplot as plt, and we also need preprocessing from the sklearn. Again, we'll read the file using the same technique, pd.read csv, copy path, paste it. df.head, and that's how my dataset looks like. Let me close it for a better visibility. That's how my dataset looks like. I think you all are familiar with the dataset, so I'll just quickly do the information. .info is giving me an information that gender and age are having null values. So we'll perform the same drop steps where we will be dropping off the columns that we don't need, which is row number, customer ID and surname. So I'll do df.drop columns equals to customer ID, row number, surname, that's it, and then axis equals to 1 and in place equals to true. Row number, I believe n is capital, and done. And if I have a look at the data set, that's how my data looks like, right? So let's say we will pick one of these columns for performing the encoding steps. Let's say we'll pick any of them, geography or gender. We can pick gender. Now gender has null values. How many null values does gender have? 54 null values. So if you simply do df.gender.value counts, you will not be able to see the null values because df.column.value counts only gives the value counts for the data points that you already have. For null values it will not show you, right? But here you can see there are 54 null values. So what we will do is we'll try to handle the null values first. Handling missing values in gender. So what we will do is we'll try to find the mode, and we all know the mode is male. df.gender.mode. What is the mode? The mode is male. So what I will do is df of gender equals to df of gender dot fill na. I'm going to fill the null values with the mode. Sorry, male. Done. Now if I do the value counts, you will see that the male count has to be increased. It has increased by the 54 values. And we'll give a quick check on the information one. You can see there is no null values for gender. All are not null values. So we'll quickly get started with the encoding techniques. So first one will be label encoding, and we all know label encoding is simply one of those encoding techniques where let's say we have gender, male, female, male, female, and so on. It will simply give them some number, give 1, 0, 1. So wherever it sees male, it will give 0, female as 1, or vice versa. And if you have more values, let's say Hong Kong, Malaysia, India, Korea, similarly 0, 1, 2, 3. Arbitrarily it will give you some numbers, which is not recommended, but let's see how to be performed. So we'll be using the preprocessing dot label encoder. If you want to have a look at it, simply just search sklearn label encoder and you will be able to get sklearn.preprocessing.label encoder. Encode target variables. You can see this particular technique is only used for target variables, which is your y variable, which is your exited column. But in this case, we are taking examples from the x variables. And I already explained you that it is not recommended for x variables. Just for the sake of showing it, I am just showing it. This transformer should be used to encode target variable, that is y, and not the input x. So let's try to see. Let's say I will define my label encoder as LE pre-processing dot label encoder, and then I will create gender. Let's say I will create a new column, gender underscore label is equals to le dot fit transform, and here I will pass df dot gender dot values. The moment I run this, df dot head, you can see there is a new column that is gender label. So wherever you see female, they have given 0, and for male it will be 1. If you want to cross check, you can cross check it by doing df dot gender underscore labels dot value count. Labels, label, value counts. You can see male and female. So the next technique is going to be one hot encoding technique. How do we perform one hot encoding technique? Let's say I have a data set. Let's say I'm talking about one of these columns called as location. So I have Spain. Some customers are staying in Spain, Germany, France. Spain, Germany, 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 France. Something like that. So what happens is you have to create 3 new columns here, as there are 3 valid values: Spain, Germany, and France. So location underscore Spain, location underscore G, location underscore France. So wherever you see Spain, this becomes 1, others are 0. Germany, this becomes 1, this is 0. France, others are 0, this becomes 1. 1, 0, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, and 0, 0, 1. And you can see the newly created features are in the form of numerical values and are in the most accepted format, which is the byte format. So how do we perform one hot encoding? There are multiple ways to perform one hot encoding. One of them is to simply use the sklearn one hot encoder, or else pandas get dummies. This is also a similar technique. Pandas get dummies also is nothing but a technique to convert it into one hot encodings. So we will be using the simplest one, which is get dummies. So I will note it as one hot equals to pd dot get dummies. Let's say I will perform it on gender, or else let's do it on geography. And you want to visualize or see your one hot, you can see 3 new columns has been created. Wherever you see France, it is 1. Wherever you see Germany, that will be 1. Wherever you see Spain, that will be 1. Right? In order to perform this task on the entire data set. Have a look at the data set. Your data looks like this. If you look at it closely, only two columns are having categorical values. Let's say I want to convert both of them into one-hot encodings. So simply what we can do is df dummies, I will perform it on pd.getDummies on df. In the same line, I will do df_dummies.head. Now you can see, so dummy variables are created. For geography, 3 variables are created. For gender, 2 variables are created. I also see a gender_label because as part of label encoding, we had also created this column, right? So make sure when you are actually performing these tasks, make sure you delete these redundant columns which makes no sense. So that's how we perform the one-hot encoding. Dummy encoding, as I explained, is very similar to one-hot encoding. The 3 columns that we are getting are called as dummy columns. And whenever you create dummy columns, based on the column that you are creating, it creates you n dummy columns. So it is always advisable to use n-1 dummy columns because one of them is just giving you redundant information. So it is fine to delete one of them. So you can delete this, this or this. Makes no sense. All of the 3 techniques are same. So we will be performing one-hot encoding, dummy encoding, which is a similar encoding technique like in one-hot encoding. So df dummies, let's say I will give it as d. pd.getDummies, I'm doing the same technique. Initially I was just doing this, but here I will use the function called as drop first equals to true. And the moment I do this and then do df_dummies_de.head, you can see that one of the features is gone. France is gone and gender_male is gone. So that is dummy encoding. One-hot encoding and dummy encoding both are techniques that we usually go for, and my most preferred technique for X variables are dummy encoding. The next one is target encoding. Target encoding is another technique. In order to get target encoding, you can simply do sklearn target encoder. This is basically present inside category encoders. So you have to install this category encoders. So what I will do is I will leave the command for installation, pip install category encoders. So in my case, this is already installed, but in your case, it will take some time to install. Once that is done, simply import it, import target encoder. Run this. Encoder equals to target encoder. So I'm instantiating my encoder. Let's say I want to create, let's say I will again read my data frame so that we have a fresh data. Read CSV, and then I will take the file path and paste it. So I have my new data frame df1. Okay. Again I will perform this technique, which is my null values imputation and this deletion. df1, drop it, and null values imputation also I will perform this technique. That's it. So df1 of gender, df1 of gender will na male. Done. Now on top of my new data frame, which looks like this, I will be performing the target encoder. So my target encoder is already initialized, which is encoder equals to target encoder. Let me reinitialize it, and here I will do df of gender encoded equals to encoder.fit transform, and then pass df of gender, df1 of gender encoded, df1 of gender, and then df 1 of exited, right? As we all discussed, target encoding is one of these techniques where we consider the target features. If you don't have a target feature, then in that case you should not perform target encoder. So once we run this and then I do df1.head, you can see that new feature is created which is gender encoded. So instead of gender you can use this new feature, and these values have been created based on some mathematical calculations between gender and exited, right? So if you want to have a look at what are the two values that are created, encoded dot value counts, you can see gender encoded, yeah, df1, so df1 gender encoded. So what are some of the drawbacks and benefits of target encoding? So I will talk about the benefits of target encoding. Target encoding is a simple and quick encoding method. Target encoding is a simple and quick encoding method that doesn't add to the dimensionality of the data set. Therefore, it may be used as a good first try technique. Now, what do you mean by dimensionality? You can see here you are creating a new column, and obviously once the new column is created, you will not consider this column. That means originally if you have x columns, you are adding one column and deleting one column. That means the dimensions remain the same. However, in one hot encoding, you are creating new features. So in this case, instead of location, you are creating 3 more features. Obviously, you will be deleting one, but still you are creating 2 more features. Imagine a column like location where you have hundreds of locations. You will end up having hundreds of columns. If you consider dummy encoding, you will end up having 99 columns. That means you are increasing 99 more features to the data. So from that point of view, target encoding is good. But we usually don't go for target encoding. At least I have never used target encoding in my entire data science career. Now, some of the limitations are target encoding is dependent on the distribution of the target. Let me just write it down. Demerits or limitations. The first limitation is it is dependent on the target distribution, which means target encoding requires careful validation as it can be prone to overfitting. Overfitting is one of the scenarios in predictive analytics which occurs when you are able to achieve a good accuracy or a good performance in your training data, but when you are trying to test it on a testing data which is unseen to the model, unseen to your algorithm, your accuracy decreases drastically. That is overfitting. But in details we will be covering that in the next session, in the next module. So these are some of the benefits and limitations of target encoding. The last feature encoding technique I would talk about is hash encoding. So sklearn hash encoder. So I'm not talking about this one. Maybe I'll just search categorical encoders hashing. Yeah, this one. So this is what I'm talking about, which is a hash encoding. It's a multivariate hashing implementation with configurable dimensionality or precision. There is a component called as n components. If you define it as 8, which is the by default number, it will create 8 more columns, 8 more numerical columns. The advantage of this encoder is that it does not maintain a dictionary of observed categories. Consequently, the encoder does not grow in size and accepts new values during data scoring by design. See, if you have a column like gender, you have male or female. Then also if you define n components are 8, you will get 8 new columns. If you have a column like location where you have hundreds of values, then also you can create 8 columns. So that's how the hashing is done. So how to create hash encoding? Simply from categorical encoders import hashing encoder, and then let's say module not found, categorical, no, category, okay. So let's say I'm going to take an example. Let's say x equals to df dot gender. I'm going to take x as my gender and y as my exited column. So let's say I will define my hashing encoding here, which is hashing encoder. Let's say I want to do it on gender column, and then I will do ce underscore hash dot fit transform x and y. The moment I do this, you will be able to see 8 new columns. Okay, and those are your hashed numerical columns which you have achieved from this gender column. Similarly, if you want to do it for geography, let's say hash 2. So in order to achieve this, you also have to change your x variable here. So you can see same 8 new columns has been created, and how they have been created is the algorithm that is doing the hashing algorithm, which is not necessary for us to understand what's happening beneath it. But overall what's happening is, irrespective of the type of values you have in your categorical feature, you are ultimately getting 8 components. If you want to change it, you have to change your n components. Let's say here, instead of the n components 8, I will use n components equals 16. To do this, 16 columns will be created. So that brings us to the end of this entire practical sessions on different feature encoding techniques, and this technique is definitely mandatory when it comes to predictive analytics. So you can see on the screen you have 16 columns, and these are hashed columns that has been created using some hashing technique. So that's all about different feature encoding techniques. I hope you understood the concepts behind it. In the next video, we shall be jumping into the use case, the case study, where we will be taking example of a live data set or one of the public data sets, and we will be performing EDA step by step and finally analyzing the insights that we will get from the data set. Talking about the use cases for EDA. Basically, EDA is important in every business problem. It's a first crucial step in data analysis process. We all know it all starts with business problem statement understanding, then data understanding, data collection, data preparation, and then EDA. Following to EDA, we have our predictive model building and deployment. So if your final use case or your end goal is building a predictive model, even if your final goal is not to build a predictive model, in either of these cases, EDA is equally vital. EDA is one of these areas, one of these topics, one of these concepts that's going to be very, very mandatory for a data analyst and for a data scientist. On which data sets, on which use cases you can perform EDA? You can perform EDA on each and every data set, on each and every case study, on each and every domain. EDA is vast. You pick a domain, you pick a use case, EDA is going to be important, because EDA is simply nothing but exploratory data analysis. In simple terms, it's initial data analysis. So some of the use cases where we use EDA are cancer data analysis, In this data set, we have to predict who are suffering from cancer and who's not. What is the characteristics of people who are suffering from cancer, and vice versa. Fraud data analysis in e-commerce, banking, financial, any areas. Fraud data analytics. In these data sets, we have to detect the fraud in a e-commerce transaction or in a banking transaction or in a generic cybersecurity world. Any domain related to fraud analytics is going to be important as well. Customer churn prediction, customer churn analysis, bank fraud analysis, customer segmentation, market segmentation. So there are so many use cases in this world in which EDA is going to be important, and we are going to talk about one of these use cases in the following video. Theoretically, we will try to understand the use case, we'll try to understand the business problem, and then we will jump into the practicals part where we will be using a basic public data set and we will be performing the EDA activities, and finally we'll come across with multiple insights from the data. So the use case that we are going to discuss is customer churn analysis. It's one of the use cases that could be applicable in any domain. Telecom, banking, financial, HR, gaming, any domain. You just pick a domain. Customer churn analysis, one of those classic examples that can be related to any domain. Let's try to understand what exactly is customer churn, and then I'll try to give examples on each of these domains so that you can relate with the case study, and once we jump into the practicals part, it will be more clear on how do we perform analysis in Python and we come across the insights. Churn simply means if somebody leaves a company or its organization. So customer churn. So churn basically means simply you have to get rid of that, or probably you just churn out or you just stop doing business with the company. Customer churn analysis simply is that kind of analysis where a customer is getting churned or not churned. Now, customers leave companies, right? With respect to telecom, let's say we have a telecom provider called as Vodafone, and probably another telecom provider which is it could be anything. You can take an example like Telkomsel or Excel Axiata or Globe Telecom, any kind of telecom examples with respect to your country, and you'll probably be able to visualize what I'm talking about. So just imagine we have a company X1 and a company X2. So both these companies are telecom providers. They provide you telecom services. They provide you prepaid services and postpaid services, right? Now imagine you are a customer of company X1. Your monthly usage is you probably use 2 to 3 GB of data, and you do probably like 50 to 100 calls in a month. And for these kind of services, let's say you pay $10 a month. If another company comes in and they start providing you the same services at $5 per month, definitely there will be a certain chunk of people who will leave X1 and probably join X2. So if these set of users are leaving X1 and are joining X2, that means it's a loss to this company. So if you are hired as a data analyst or as a data scientist in this company, your main task will be to understand this pattern, to understand what are the characteristics of the people who are leaving the company. Are they leaving because of some offers like this, or are they leaving because of some service impact or anything else, right? So there are multiple reasons why a user leave a company and join another company. One reason is this. One reason is probably a customer is genuinely irritated with the service. Wherever he goes, maybe he's a hiker. he goes for mountain hikings, and wherever he goes for hiking, he's unable to call anybody because of the bad network. So definitely he will get pissed off and probably churn out, and he will probably join X2 or X3 or any of their competitors. That means that particular customer is churning. Similarly, with respect to banking, imagine you are currently an HSBC user. You are using HSBC bank account for all your transactions, for your for your salary and all those things. You are doing some freelancing work, every kind of transactions you are using HSBC. Or simply, let's talk about HSBC credit card. You are using HSBC credit card. Now, Standard Chartered comes with a plan, with a better plan. They come with a credit card better plan that if you start using their credit card, you will get twice or thrice more points as compared to HSBC or any other credit card holders. There will be certain amount of people who will start using Standard Chartered, and with due course of time, their usage with HSBC will decline. Now, that is again a churn scenario. A customer is getting churned from HSBC to Standard Chartered. Talking about HR, many people leave companies. Today, you are working for Amazon. After 1 year, probably you have some fight with your manager, or probably you are not getting that much of salary that you are expecting, and you got an offer from Google at a double pay, you will churn. So again, multiple reasons why people churn companies. Maybe because of better pay, maybe because of location, maybe because of a bad manager. Could be anything. Talking about gaming industry, imagine you are playing a game. Let's say I will name it as game 1. You started playing this game. After 5 to 7 days, you almost reached 100 levels. You see that the game is too easy. With just one attempt, you are able to clear all the rounds. So at certain point of time, you will feel bored and you will churn out. And you will start installing another game and probably uninstall G1. So G1 will be uninstalled, probably will install G2. Or else, you started playing this game for 5-7 days, you are stuck at level 142. You are stuck for the last 2 days or 3 days. You get pissed off and you churn because the game is too hard. So any kind of use case, any kind of industry, there will be a certain amount of customers, those will be churning. So churn is one of those common use cases that usually happens in any kind of industry. In this particular video, we will be focusing more on the telecom churn. So we'll talk about telco churn. In simple terms, telco is nothing but telecom. Right? Now, theoretically, I will explain you all the things, and once we jump into the practicals part, anyways, we will be having a detailed step-by-step process. So the use case is very clear. We have a data set, let's say 10,000, 20,000 records. Certain amount of people that have churned, let's say 2,000. And let's say 8,000 people are active. And of course, there is a column, let's say exited. And this column is telling you about this thing. Churned, active, and so on. And there are multiple other columns. What is your final goal when you receive a data like this? You are working as a data analyst for that company. Your task is to perform EDA, initial data analysis or exploratory data analysis. And as part of EDA, you should come with insights that talks more about the churned customers. That means you need to come up with features, or you need to come up with some insights that is triggering or causing the churn, and what is the potential characteristics of those people. Let's say out of those 2,000 people, you got to know that 1,800 of them are females. Now that's an important insight. Most of the people who are females are churning more. Or maybe out of those 1,800, probably 1,600 of them are from a specific location. That means from that specific location, there could be a problem in that location. That's why people are churning, right? So you come up with insights, and your ultimate goal after EDA is to showcase the reports, showcase the insights to your higher management or to your customers. And once they go through them, if that is convincing, your final goal is going to be creating a predictive model which will be able to predict for a new customer whether that customer will be churned or not churned. That is the entire customer churn analysis and prediction use case. In the practical session, we will be using a data set like this. So the steps that we will perform is, the first step we will perform is, of course, we will be checking we will be doing data cleaning. And data cleaning, definitely it's a one-step process in EDA especially, but when it comes to predictive model part, you could, data cleaning could be an iterative process. You could perform some cleaning activity, create your model. If your model performance is good, fine. If it is not good, you can again come back and do another way of data cleaning, right? But especially for EDA, there is nothing right, nothing wrong in the data cleaning part. Inside data cleaning, we will be handling all the null values. Wherever we see null values, we will be handling them. Null values occurs because of multiple reasons, right? It could be because of your script, because the null values are actually there in the database, or it could be anything. But you have to deal with it. So we all know how to deal with null values. The simplest technique is MMM, which is mean, median, mode, right? For numerical data, it could be mean and median. For categorical data, it will be mode. After null value imputation, we also go ahead and do some other checks for invalid data type. We also do some outlier treatment, or kind of check outliers, whether our data has outliers or not. Once all this cleaning process is done, then we start with our analysis. Again, analysis is split into multiple things. First, we try to do the categorical analysis, and then we do numerical analysis. In categorical analysis, we mostly do the univariate, bivariate. If time permits, we also do multivariate. But multivariate could be very much time consuming, so it all depends. If you have time, you can do it. And when it comes to numerical analysis, again, with one numerical attribute, we probably get some summary statistics, and with multiple numerical attributes, we probably go through their correlation and all those kind of things, where we check the relationship between various numerical attributes, and also relationship between numerical attributes and the y variable, which is exited or not exited, how these numerical attributes are impacting them, right? All these things we do. Now we'll quickly try to understand about univariate analysis. Univariate simply means single variable, right? Let's say you are talking about gender. You simply go ahead and check what is the distribution. Out of the 10,000 customers, let's say the distribution is almost even, 5,050 and 4,950, almost 1:1. And again, you do the same thing for the churn customers. Now let's say again there is an even numbers or even ratio, almost 1:1. You find that gender is not that important from the univariate point of view. Or else if you come across a situation like this, probably you can end up telling that more males are likely to churn. Moving on to bivariate analysis, we combine another variable to it. Let's say gender plus location. Again, you do the same thing, male, female. You check with multiple locations what is the ratio, and again you do it for only for the churn customers, and then you compare. What is the original churn rate? It is 20%. What is the churn rate here? Let's say for male customers staying in France, the churn rate is 40, which means people, especially males who are staying in France, are more likely to churn. Similarly, if you want, you can also perform multivariate, which basically means you have to combine 3 or 4 variables together and start analyzing it. Finally, when we do numerical analysis for single numerical attributes like age, tenure, and all those things, we try to check their summary statistics. And if with multiple numerical attributes, we perform. Firstly, we try to check their, if there are less amount of numerical values or numerical variables, you can simply draw scatter plots between them. If there are huge amount of numerical features, you can go for the correlation matrix, CORR matrix, which tells you about each column versus each column's correlation value, right? So these are different analysis that we usually do. At some point of time, we can also do some derived metrics, which basically means some of the columns that are present in your original data set, but sometimes you have to create new columns. For example, simply age, you are not able to understand any pattern because age is a continuous numerical variable. So what you need to do is you need to create some bins out of it so that you can visualize the bins. So that comes under your derived metrics. So that's overall about the EDA process. In the next class, in the next video, we shall be jumping into the practicals part, and I will be taking help of a public data set, and I will be doing an end-to-end EDA case study so that you can understand everything about what's happening. And exactly similar kind of things you can also do it for any other public data set as part of your project. Let's move into the practicals part. So we will be talking about customer churn analysis. We have the data set. I will be showing you the data set on how it looks like, and we'll get started with the entire EDA process. To get started with, the first thing that we need to do is going to be importing the libraries. In parallel, I will also be noting down the different steps that we are performing for the entire EDA process. So I'll quickly open the paintbrush so that we can have the steps written down here. Importing the libraries. That's the first step. So in this case, we are importing NumPy, Pandas, Seaborn, Matplotlib, and whatever libraries that we have used, we can import it. So I'll quickly run it. The data set that I'm going to use is customer churn.csv. You can see this is how it looks like as we have opened it on Jupyter Notebook. But yeah, if you download this file and open it on Microsoft Excel, you will have a better look. It has multiple columns starting from customer ID till the churn. Now, just to let you know that this is not the same data set that we have used in the previous videos. It's an updated and upgraded version of it with more features. You can see there are more features here: gender, senior citizen, partner, dependents, tenure, phone service. So many features are there, and we also have our Y variable, which is the churn. Our ultimate goal for this use case is to create a model which will be able to predict whether a customer is churning or not. But in our case, for the time being, we are performing the EDA. So we will majorly be focusing on what are the driving factors or what are the most important factors of people who are churned. What are the insights, right? So jumping back to the code, we will be reading that file using pandas.read_csv. In case you are using an Excel sheet, you can simply use read_excel and then pass the path. That's it. File name .csv or path.csv. One more thing to understand here is, as I am showing Jupyter Notebook and it is in my local machine. Let's say my file is not present in the same folder as my Python notebook. Imagine my file is present in a completely different directory. In that case, you have to pass the entire path, else it will not be able to read the file. In case you are using Google Colab, you will have to upload the file, or else you can use it directly from your Google Drive by creating a connection from your Colab to Google Drive. That's not a big deal. You can simply Google it out whenever you are stuck. You will be able to figure this out. My data is read. Now this is the data frame that we are going to use. Pandas.csv, this is the data frame. So the first thing that I'm going to do is look at the top 5 records of the data. To look at the top 5 records, you have to use .head function, which comes under your pandas library, right? Now this gives you a quick glance of the data. In case you want to have another glance at the bottom of the data, you can simply do df.tail. That's it, df.tail. Check the various attributes of data like shape, rows and columns, data types. So this is again one of the most important things. Before getting into the analysis part, you should be aware how much columns are we dealing with, how many rows do we have, what are the different column names, and so on. If you have already seen your file, then completely okay. But if you are directly seeing it as part of your pandas data frame, then it is a good practice to perform these activities. So df.shape gives me an idea that we have 7043 records and 21 columns. df.column.values will give me an idea about all the columns that I have. Similarly, if you want to check the data types, anyways, df.info will give you that information, but we have a special method as well called as dtypes, which will tell you that which column is of which data type. The next thing is checking the descriptive statistics of numerical variables. Now in this case, you can have a look at it. How many numerical attributes do we have? We have senior citizen, we have tenure, and we have monthly charges. Nothing else. Everything else is object, means string values. Only 3, which is senior citizen, monthly charges, and tenure. From this point of view, I see there is a problem. The problem is here. Total charges should have been an integer value, should have been a integer or float value. In fact, should have been a numerical attribute, but it is not. So we will try to keep this in our mind right now. Anything else, I don't see any problem anywhere else. .describe is going through the entire data frame and it is only returning you 3 columns. Why? Because these are the only 3 columns that are having int or float type. So you are getting this information. But if you look at the data carefully, senior citizen is having 0 or 1. Basically means 0 means non-senior and 1 means senior. So my intuition is, even though it's a numerical attribute, it should not be treated as a numerical attribute. It is more of a categorical attribute where you can have no and yes, right? That's why I will ignore this box of senior citizen. I will only consider tenure and monthly charges. So from tenure, what do I get? The mean tenure is 32 months. Probably it could be months because 32 years does not sound good. 32 months. 29 is your median value. So I don't see a huge difference between mean and median. So I think there are very less outliers. The maximum value is 72. 75% of the people are less than 55, right? 75% of your customers are having tenure less than 55 months. Only 1/4 of the population is having more than that. From the monthly charges point of view, mean is 64, median is also 70, almost similar. Maximum is 118, 89. So average monthly charges is almost 65 USD, but almost 25% of the people are paying more than $90 per month. Again, not a huge insight, but this is what I'm visualizing the data. So you can note down what you see. Whatever things you see, you can note it down. So I have noted it down here. Senior citizen is actually a categorical, hence the 25, 50, 75% distribution is not proper. 75% customers have tenure less than 55 months. Average monthly charges are this. The next thing that I'm doing is, as I know that this particular dataset has a column which talks about whether the customer has churned or not churned. So I'm quickly doing a value counts on that particular column. So my value counts is returning me this. If you further have to see the distribution with respect to percentage, you can simply do this. Value counts divided by the total length of the data frame multiplied with 100. That will give you an idea that the distribution is almost 73.4 is to 26.5, which means the total churn rate of the data you have is 26.5. Now that is high. As a data analyst, you should be able to understand the pattern of the people who are churning. And as a data scientist in the future, your main goal has to be creating a model so that the model can predict any existing customers that are probably likely to churn in the next 6 months or 12 months. And if you're able to do that by providing them offers, you will be able to retain them. So this percentage goes down, the revenue of the company goes up, and you are doing justice for your job. That's how the relationship between analytics and the data science part is, right? Coming back to the topic, here I am simply building a bar chart using my value counts. So I have my DF of churn value counts. I am plotting a bar H. Bar H means a horizontal bar chart. If you do simply bar and you run this, you will get a graph like this. If you run it on a bar H, you will get a horizontal chart. It depends on what you would like to achieve. In my case, I'm completely okay with bar or bar H. Pick size is basically showing you how big your figure should be. If you need to shorten it out, you can shorten it. Up to you. X label and Y label are basically given to provide the labels. You can see your X is count and Y is target variable. And title is count of target variable per category. Simple. If you want to make it very clear, count of customers per churn category. Looks, anyways, let's not complicate things. So things are good, right? So you can see this plot. This is the same step that we performed, 73 is to 26. So I'll try to skip this part. My value counts is also clear. For no, we have 5174 and yes is 1869. Now, what is the insight here? The insight here is the data is highly imbalanced. It is not in the ratio of 1:1, and almost 74% of the people are active and rest are getting churned, right? So our further insights analysis has to be done to understand more about the people who are churning. Then I'm doing a .info concise summary of the data frame. As we have too many columns, we are using verbose equals to true. Verbose equals to true, I'm not using it, so I will just, that's it. I'll just remove this part. Verbose equals to true is another thing. For example, you are dealing with a data set where you have hundreds and thousands of columns. In that case, what happens is you will not be able to scroll it properly. You will not be able to see all the columns. If you mark verbose equals to true, it will be scrollable and you can scroll through all the columns. In this case, we are just having 21 columns, so we don't need that option. So I'm just using .info, which basically gives me an insight like this, and I could see that most of the records here are completely okay. There is no null values. But one problem is total charges. You can see total charges is an object type. and object basically means a string type. And if total charges would be having null values, then that null values will be treated as not null because it's an object. Because empty value is also a valid object, right? So we need to be careful about total charges. What I need to do is I need to convert this into numerical and then again check the dot info, and again if I see 7043, then I will 100% be sure that there are no null values. The next piece of code is a very generic code that you can simply use it in any kind of use cases. This gives you a picture about the entire data set on what are the total percentage of missing values. So you can simply see I'm just using the pd.data frame df.isNull.sum. I'm multiplying with 100 so that I can see the percentage of the null values divided by df of shape.reset index. The code is little bit complicated. If you take some time, you will be able to understand it, but you can simply copy paste this piece of code in any kind of use cases that you are working with. Blindly, you just have to deal with all the variables. If all the data types are completely fine, just blindly copy paste this code and you will be able to get a graph something like this, which talks about the percentage of missing values of all the columns in your dataset. So the missing data initial intuition. Why are we capturing all these insights after every step? Is because your final EDA, the output of your EDA are insights. Your output of your EDA has to go to your higher management or to your customer so that they will be able to understand the summarized data. Nobody will be able to see at your code and understand. Coding is for people who are into analysis, people who are the engineers, right? For non-coding people or for higher managements, they understand visuals, they understand your final insights. So you have to be good enough to, whatever you have understood in the EDA process, you have to be good enough in the data storytelling part. You have to be good enough in your visual analytics so that you can portray them a proper insights. So the missing value, missing data initial intuition is that here we don't have any missing data. General thumb rules. Again, here we don't have any missing data, but there is something in my mind that total charges data type is not proper. So in the data cleaning part, I will be dealing with that and I will again do the missing value imputation. So it has to be a repetitive process. The general thumb rules for missing data is, for features with less missing values, we can use regression to predict the missing values or fill with the mean of the values present. For features with high number of missing values, it is better to drop. So it simply means that if you have a column, let's say age, and 70% of the column is empty, there is no need of imputing, because if you impute, that means you are manipulating almost 70% of the records, which makes no sense. So you can simply get rid of it. But before getting rid of it, you should also analyze, is there any column that is impacted by this column? Or is there a column that impacts this column? One example will be, let's say, I'll talk about a scenario, not specific to customer churn, a generic example. Let's say there is a column called as car type. You are analyzing some insurance related data and there is a column called as car type. 70% of the data points are null. So some of them is SUV, null, 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 XUV, null, 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 SUV, and so on. Will you be able to delete it because it has 70% null values? Before deleting, you will have to analyze all the columns. Is there a column that impacts this column? Let's say there is a column called as is car. And the records are something like this. N, 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 Y, N, 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 and then Y. Which basically means if somebody has a car or not. Somebody has a car, the type is SUV. Car, type is XUV. Car, type is SUV. Obviously, people who don't have a car, they will have null values, right? So in this case, instead of dropping this column, I will just simply impute it by no car. No car. Right? So this is a better technique to impute data. So before dropping, there is a general thumb rule to drop. If you have more than 50% of the null values in the entire column, drop it. But before dropping, try to use your domain knowledge, analyze it, whether that column is impacted by another column or any other column that is getting, any other column that this column is getting impacted from. Any of these things. Then try to analyze them and deal with it. In case you have any doubts, any questions, you can always ask your peers, your superiors, your people who are basically managing you for any kind of doubts before taking a final call. But again, there is a catch here that this is the same example that I took and you can take your decisions wisely. That's all about very initial steps. In the next video, we shall be talking about the data cleaning part. Jumping into the next part, which is your data cleaning part. Now in this part, we will be doing some data cleaning activities, which includes conversions of invalid data type to another data type or some null values imputations and so on. Let's get started. So we already had this data frame called as DF. I don't want to impact anything for this particular data frame. So I'm taking a copy and I'm creating another data frame. And this is a common practice in EDA or whenever we write codes. We don't, at some point of time, we feel that we should take backups, and it's a good step as well, right? Because you don't impact your variables further. So I'll take a backup of my DF. If something goes wrong, I can come back easily. And then I will be creating a new DF, which is very similar to what DF was. If you want to have a look at it, this is how your new DF looks. A replica of DF. Total charges should be numeric amount. As I told you that total charges was an object type, your focus should have been to create it as a numeric. There could be multiple instances where your data is numeric in Excel sheets or in your CSV files. While reading the data into Pandas data frame, it could be treated as an object type. There could be scenarios. So you always have to keep an eye and convert those type of columns to numeric so that you can do the further steps. So total charges should be numeric. So I'm converting them into numerical data. So df, new df.total charges is pd.toNumeric. Now pd.toNumeric is used to convert a data frame column to numeric attribute. And I'm passing total charges, error equals to coerce. And then I'm doing new df.isNull.sum. You do this or you do new df.info, both are same. You can see the output of this is very clear. Every column is having 0 null values. Total charges is having 11. If you also want to check the traditional approach of info, you can do that. Info is telling me that I have 11 null values in total charges. If you remember, in the DF, where we have not imputed anything, total charges was showing as 7043, not null values. That means no null values. But that is a wrong assumption because it was an object type. Now I can see there are null values. How many null values do we have? Just 11. Now, sometimes we ignore very small amount of null values. If it is just 5 or 6 records, just 1% of the data, then it is better to ignore. What information will be there in just 11 records, right? If I talk about the percentage of data, 11 by 7043 multiplied with 100 is not even 1%. It is less than 1%. 0.15% of missing values. What should we do? There are two techniques. One of them, just impute it, and as total charges is a float object, you can impute it using mean value or median value. But I will delete it because another step is also to delete it because there are just 11 records, just 0.15 percentage. So even if I delete 11 records, I don't think that I will miss out on a huge amount of records, huge amount of information. If the total percentage would have been 2 to 3% or 5% or 10% or even till 30%, I could have easily imputed it, because you cannot simply delete 30% of the records. It's almost 30%, but in my case it is just 0.15, so I will delete it. So these were the null records, and then I'm doing a missing value treatment here. Since percentage of these records are very low, it is safe to ignore them from further processing. So I'm doing drop NA how any in place equals to true. Okay, so removing all the missing values. Divide the customers into bins. So my data cleaning is almost done. Invalid data type is fixed, null values are imputed. The next step is I have a column called as tenure. Now you cannot simply go ahead with this step. So EDA is basically an iterative process. Now it's very difficult to say why I came up with this particular step, but the thing is that I didn't perform this step. Initially, after this, I was directly jumping into this particular step where I'm removing some random columns, and then my cleaning is done and I'm further doing my analysis using graphs. And when I was doing analysis using graphs, I came up that I kind of understood that tenure is a continuous variable, and plotting the tenure graph was not giving me any insights. So I had to again come back to this particular step and I performed this step. So I kind of helped you to understand why I'm performing this step. But in your case, you can simply check out your data, get an intuition if there is a continuous numerical column like age, tenure, something like that. You can simply convert it into bins or simply do a feature binning. So we are conducting feature binning right now. As we have a column like tenure, it is very difficult to visualize a continuous variable, right? You could end up having a lot of bar charts. You will not be able to understand and get insights. Even in line chart also you will not be able to understand. So better way to understand will be having bins. If you convert it into 3 or 4 bins, you will be able to understand that majority of the people are lying here, or people who have churned are mostly from this category, right? So I have divided the data into bins. New df tenure max is 72. So here I'm creating labels. My labels are these. Run it, and then I'm creating a tenure group, and you can see my tenure group dot value counts are something like this. So 2175 records for people who are in 1 to 12 category, 61 to 72 1400 records, 1024, and so on. After that, as part of the data cleaning process, I'm also removing some of the columns that I know they should not have been a part of this particular data set for analysis. Let's say I will try to see the data frame. Customer ID is definitely one of those columns. I don't need customer ID because customer ID will not give me any information. It's a randomly generated number. Apart from that, we also have created tenure group. So I don't even need tenure because my tenure group is already there. So I don't need tenure. So that's why I am removing customer ID and tenure from my x-axis in place true. If I do this and then I do data frame.head, you can see those columns are gone. So that potentially brings us to an end to the data cleaning process. I hope you understood each and every step. In this particular data set, we didn't had enough null values, but yeah, in your case, there could be different null values. There could be different columns where you need to combine them to get an aggregated value. There could be scenarios where you have to drop multiple columns. So the number of scenarios are too much. It's very difficult to explain taking just one single example, but I hope you are getting into the process. You are trying to understand what's happening, and it's an iterative process, right? You have to work on multiple EDA projects to become a EDA wizard in order to be a professional or somebody who has good experience or knowledge into EDA. You need to work on multiple projects. So that's all about this particular video on the data cleaning part. Our next part is going to be our analysis. Because the data cleaning part is done, we assume that our data is cleaned data right now, and now we are ready for the analysis part. See you in the next video. So we will get started with the data exploration part. Till now, we assume that our data cleaning process is done, and the expectation is the data right now is almost cleaned. Now our next step is to perform different types of analysis that includes univariate, bivariate, multivariate, numerical analysis, and so on. There could be multiple instances where you could also realize that there could be a problem in the data. You are not able to interpret. You again have to go back to the data cleaning process for further cleaning or further changes, and then again come back to the analysis process. It is a possibility, but we assume that in this case, in the case right now we are in the state we are in, we assume that our data is already cleaned. Let's get started with the different types of analysis. In this video, we shall be focusing more on the univariate analysis part, and going forward we will have numerical analysis, bivariate analysis, and so on. So we already have the data set, we already have the data frame, the new df.head. It has columns like these: gender, senior citizen, and so on. So in the next step, what I'm doing is, ultimate goal is to perform univariate analysis. Whatever columns you have, gender, senior citizen, partner, you are free to create multiple charts. You are free to have one line of code for one type of chart. So one by one is also possible, but I have already automated this process. Hence I am running a for loop where I will iterate over the entire data frame, and I will be able to plot everything in one single line. So just 3 lines of code I will run. It will iterate through the entire data frame, and I will get a whole list of all the graphs, all the univariate graphs, right? So I'll try to explain this piece of code. It's not rocket science. Here I am enumerating, or basically iterating over the data frame. From the data frame, I have deleted all my numerical columns and the churn column. Why? Because churn is our output, my y data, my dependent variable, and total charges and monthly charges are my numerical attributes. So we will be doing numerical analysis for these columns. Apart from that, do we have any other numerical columns? We have senior citizen, but as I told you, it's in the format of 0 and 1, could be considered as a categorical attribute. So I am not dropping them. Apart from that, I'm just doing plt.figure, and I'm doing a count plot. If you want to have more understanding on count plot, simply go ahead and search cbond.countplot. You will be able to get the information about it. It is simply a bar chart. Counts of observations in each categorical bin using bar. I'm passing the data frame, my predictor, and my hue. Predictor here is nothing but all my columns. I is nothing but the number of columns, the index values. Hue is churn. So I have already ran this command, so I have the list of visuals in front of me. If you want to add labels, you can add them, but labels are not that important because somehow from this graph itself I'm able to interpret some of these numbers. So we'll try to analyze one of these graphs, probably couple of these graphs. So let's say I'll talk about the first one. That's my gender. What is my original data distribution? If you forgot, probably I will create a line of code here. New df dot churn dot value counts. So my original data, I'll just do length of df, length of new df, and then into 100. Almost 26.57, 26% is my churn rate. That is my churn rate, right? So I'll try to analyze this graph first. I have gender, I have my hue as churn. So this is my not churned and this is my churned, right? So how many churned customers for female? I don't know exactly, but let's assume around 900. And not churned almost around 2500 or 2550. Okay, somewhere around that. So what is the churn ratio here? The total is 900 plus 2550, around 3450. So almost 900 churned, 3450 multiplied with 100. Almost 26% of the female customers have churned. Almost. What about male? I see a similar numbers, maybe 900 and maybe a little bit more than 2550, could be 2600. Now what is my churn ratio here? 900 divided by 3500 multiplied with 100. Almost 25.7%. I would assume it's almost 26, right? So what my gender is portraying me? The gender is portraying me nothing. I'm not able to get any insights from only the gender column. Does that mean gender is not important? No. Gender could be combined with any other feature to become a powerful feature. But alone, standalone, gender is not a triggering point. Gender is not impacting the churn. So, coming back to the second graph. Let's say we'll talk about senior citizen. Senior citizen, I'll again take this and then paste it. Now, original data, 26%, remember this in your head. How many churned customers? Again, I probably don't know exactly, but around 1300. Okay, you can take help of value counts or take help of any other technique to find these exact numbers, but I am just taking the rough numbers. How many not churned? Probably around 4500, I would say. Okay, so what is the ratio? 1300 divided by total, which is 5800. Almost 22%. 22% of the people who are not senior citizen are churning. What about senior citizen? Around 400 or 500 are churned, and around 600 or 700 are not churned. So 400 divided by 1000 into 100, almost 40%. So senior citizen almost 40%. Now this is where we got our first insight. What is the insight? Senior citizens are more likely to churn. That is my first insight. Similarly, you have to go through each and every graph to interpret some analysis, interpret some insights. Now I will skip these columns like partner, and you can see in the partner also, people who have no partner, they are more likely to churn. You can see the active customers are less in case of no, but churn customers are high. If you talk about the ratio, probably I could say, let's say around 1300 churned and around 2400 not churned. The total number of around 3700 into 100, around 35%. Around 35% churn rate for people with no partners. So my second insight could be people with no partners are more likely to churn. So that's how you build up your insights. You start analyzing data, univariate, bivariate, combine multiple variables, and then come to a conclusion. I'll quickly jump into one more important feature because I have already analyzed this data. You can do the same step for each and every graph. So I'll quickly skip to a feature called as contract. Okay, contract is an important feature. So I will take the screenshot using a snipping tool, and then probably I will do it here. Okay. Now from this particular graph, how many monthly customers who have churned? Around 1200. How many total not churned? Around 2400. Exact numbers again I'm not sure. How many 1 yearly customers? Around 200. And how many churned? How many not churned? Around 1300. How many people churned? Around 100 or 200. How many not churned? Again around 1700 or something. So what is the ratio? Let's try to calculate. For monthly customers, 1200 divided by 3600 into 100. Almost 33% of the people are churning. Sorry, not 1200. You can see the orange graph is too high. Almost 1700. Almost 1700. So there is a mistake here. Almost 1700 divided by total would be 4100 into 100. Almost 41% of the people who are having monthly contracts are churning. What about 1 yearly? 1 yearly is around 200 by 1500 into 100, around 13%. And 2 yearly is around 5%. Now this feature, let me explain you about this feature. As you might be having domain knowledge, you can understand the meaning of the feature. Here this feature basically means contract. Now how does contract works in telecom? Here we have three contracts: monthly contract, 1 yearly, 2 yearly. Now if you have a 1 year contract, that means even if you don't like the company, even if the company sucks, even if the company has bad offers or bad service, anything, you cannot leave the company without paying the entire fees of 1 year because you are bounded with a contract. So it is quite obvious that less people will churn. Same with 2 yearly, less people will churn. But monthly customers are free. If you have a problem, service problem, or anything goes wrong, they will quickly churn and jump into another company. So it's a very quite obvious insight, but an insight is an insight, right? So the insight is monthly contracts are more likely to churn because they are free customers. Free customers as in they don't have any contract. Jumping back to the univariate analysis, similarly you have to do further univariate analysis. You can see payment method. The first category is electronic check and very high percentage of churn ratio, right? So again, another insight would be people who pay via electronic check are more likely to churn. Electronic check more likely to churn. Similarly, you have to go through each and every graph to interpret some analysis. There could be scenarios where you can get insights very easily. There could be scenarios where you might not get insights, and if you don't get insights, then you have to dig into your bivariate analysis, multivariate, and so on. So overall, that's all about univariate analysis. In the next video, we shall be talking about numerical analysis, and then in the future we will jump into the bivariate analysis part. Jumping into the numerical analysis part. Numerical analysis, we all know that we do this kind of analysis with numerical attributes. Single numerical attributes or multiple numerical attributes, we have to perform some analysis. So before getting into the numerical analysis part, I have done some codes. Probably I will explain that. So here I am creating a new data frame only for the people who are active, and again another data frame with target 1 for people who are not active, who have churned. So I'm basically dividing the data into churned and active users. Talking about the churned users, how does my gender look like? 939 and 930, female and male. Similarly, if you talk about the original data, the ratio is almost 1:1. Here also it is 1:1. So if you want to do your univariate analysis using graphical or visual analytics, you can do. Without visual analytics also, you can do like this. So getting ahead with the next things that we have done, here I am creating a cross tab between payment method and churn, which basically tells you that for bank transfer, people who have churned are 258, not churned are 1284. For electronic check, it is a 1:1 ratio. You can see 1:1 ratio. So if you talk about how many total electronic check do we have? 1071, which is 2365. 2365 into 100. Almost 45% of the people who are using electronic check are churners, right? And this is what we already got from the previous graphs, from the univariate analysis part, right? So jumping into more into the numerical part. So in order to continue with the numerical analysis, it is better to convert the target variable into numerical attributes as well. So here I am converting my churn into 1 and 0, and if you see I am plotting the dot head, you will see that churn has been converted to 1 and 0s. Why we have done? Because we will be doing some correlation things. We will be calling correlation function, and those statistical and mathematical functions might not work with categorical data. So we are converting into 1s and 0s. We are also converting all the categorical variables into dummy variables. Now, a flashback to the feature encoding techniques. I told you that there are multiple feature encoding techniques, which includes label encoding, one-hot encoding, dummy encoding. Here we are performing a dummy encoding. So I'm calling pd.getDummies and I'm converting my data frame into dummies. So now you can see initially I had less amount of columns, around 20-21. Now I have 51 columns because dummy variables has been created. Okay. For each payment method, multiple dummy variables has been created. So we'll first analyze the relationship between monthly charges and total charges. Okay. I know somehow, using my domain knowledge, I already know that monthly charges and total charges are positively correlated. But I just want to plot it. So I'm using an LM plot and I'm passing my dummies data. In the x-axis I am passing monthly charges and y-axis I am passing the total charges. So I'll run this and you can see that somehow for some data points it is difficult to interpret, but most of the data points I can see an increasing trend, right? if you want to calculate the correlation, you can see between monthly charges and the total charges, I am calling the correlation function, and the correlation is 0.65. And we all know that correlation value ranges from -1 to 1. 1 being the highest, -1 being the lowest. If the number is very close to 1, that means they are positively correlated. So in this case, the variable is positively correlated. That means monthly charges and total charges are correlated positively, right? So my insight here will be total charges increase as monthly charges increase, and vice versa as expected. So again, you can go back to your insights. If you want, you can note it down. So let's try to note it down. Monthly charges and total charges are positively correlated. Okay. Going back to the code. So here I am performing some activities to plot some kernel density plots, churn by monthly charges and total charges. So here I am calling my monthly charges on my active users and the same thing on my inactive users or exited users or churned users. And then all these are very simple. I'm just passing the legends. Y label, X label and title are very simple. This is the main piece of code. So here I'm calling cbond.kd plot, which is a kernel density estimation plot, and I'm only plotting my monthly charges. If I run this, that's how my graph looks like. Now, if you look at it closely, you can see the insight that I'm getting from here is the churn, which is the blue graph, is very high when the monthly charges is high, and the churn is very high when the monthly charges are low, which is quite expected, because if the monthly charges are high, maybe because of the monetary aspects, the customers are churning, right? So this is an insight. So again, let's go back to our insights part and try to write it down. Churn is high when monthly charges are high, right? Similarly, I will do it for the total charges. So as monthly charges and total charges are positively correlated, I should also be seeing a similar kind of pattern. More total charges, more churn. Less total charges, less churn. Let's see. Astonishingly, you can see that the churn is high at less total charges. Even though total charges and monthly charges are almost highly correlated, but this is a very surprising insight. So the insight here is surprising, as higher churner at lower total charges. However, if we combine the insights of three parameters, tenure, monthly charges and total charges, then the picture is bit clear. Higher monthly charge at lower tenure results into lower total charge. Hence all these factors, which is higher monthly charge, lower tenure and lower monthly total charge, are linked to high churn. Surprising insight, right? The next step is nothing but I'm building a correlation matrix or correlation graph of all the x variables or all the predictors with respect to my churn column. So I'm calling my data frame dot correlation function. With respect to churn, I am sorting the values with ascending equals to false, which means descending is true. Dot plot kind equals to bar. So I'm plotting a bar chart. If I run this, the graph looks like this. Now, what do I infer from this graph? So let me just zoom out a little bit so that I can snip out the graph. I'll take it to my paintbrush for a okay. Now you can see the first the first thing is ignorable. The first bar is ignorable. Why? Because it is churn, and we are building this function with respect to churn. So with respect to churn, the correlation will anyways be 1, right? So ignore this graph. Talking about this graph, contract month to month. So this graph basically tells me monthly contractors are more likely to churn. We have already got this insight here. Number 3. Online security, no. People who don't have online security are high churners. New insight. So you can write down here. Tech support, no. Tech support, no, are high churners. Tenure group of 1 to 12. So people who are in the company between 1 to 12 months, that means all the new customers, are more likely to churn. Internet service, fiber optics, more likely to churn. Payment method, electronic check, more likely to churn, and so on. So we set a threshold by ourselves. Let's say I set my threshold as 0.2. So probably anything that goes beyond 0.2, I will choose these as my important predictors. Similarly, I will also choose a set of predictors who are also negative correlated. They will also help us in the model, right? Contract 2 year, good insight, they are low churners. Streaming movies, no internet service, low churners. All these are low churners. You can see tenure group 61 to 72, which means people who are in the organization for a longer period of time, they are low churners. So these are all the insights that I'm getting, right? Jumping back to the code, high churn seen in the case of month to month contracts, and these are all the derived insights. High churn seen in case of month-to-month contract, no online security, no tech support, first year of subscription and fiber optics internet. Low churn is seen in case of long-term contracts, subscriptions without internet service and customers engaged for 5+ years. Factors like gender, availability of this and number of multiple lines have almost no impact on churn. This is also evident from the heat map below. So I am running the correlation function with respect to the heat map, with respect to the entire data frame. Heat map basically tells you the correlation between each and every feature. But the previous graph is telling you the correlation between your target variable. So both are different. Now in this case, we'll try to spot a darker shade of this one. Let's say this one, senior citizen, and payment method bank transfer automatic. They are kind of having high positive correlation. So all these kind of graphs will give you an insight about the different types of relationships, right? But more likely we got more insights from this particular graph. Apart from this, the way we did for our total charges and monthly charges, in case in your dataset you have more numerical attributes or more numerical columns like salary and other things, you can also do the same technique. Let's say I want to do it for churn. I want to do it for tenure. But however, I don't have tenure. I have already converted my tenure into tenure groups. So I don't have that column. So I might not be able to do this for tenure. But just in case you want to do it for tenure, I think we already have, let me just delete it. We already have a backup data frame, right? In that we have tenure. So we can just quickly go through that and plot this. Let's say df dot tenure, df with respect to churn. Here we have no, so I will just change it to no. df dot tenure, df of churn, yes, and everything remains the same. This is not total charges, this is going to be tenure and tenure by churn. Let's run this and you can see that less less tenure people who are new are high churners, and people who are having more tenure are low churners. Very good insight, right? Similarly, if you have any other numerical features, let's say tenure is gone. I think other than that, I don't have any other numerical features. But in your case, if you have age, salary, and other things, you can simply copy paste this code to understand the kernel density estimation plot, and you will be able to infer something. So that's all about numerical analysis. In the next video, we shall be focusing on the bivariate analysis. Our next type of analysis is going to be bivariate analysis. However, for this particular use case with univariate and with the numerical analysis that we have done, almost we have got a lot of insights, but bivariate is also going to give us more insights. So I have divided the data into target 0 and target 1. First data frame is about the non-churners and the second one is about the churners. I'll do this. The non-churners are 5000 and the churners are around 1869. I have created a function here, uniplot, where I'm taking input some data, column and title and hue, and I'm writing down some pieces of code to plot something. Now this again is a reusable code in case you are doing EDA and you are performing some bivariate analysis. You can simply reuse this code. So I'll not be explaining you this code. I will jump into the plot part. So here I'm just calling my uniplot. I am passing my data frame, which is my target 1. That means people who have churned. I am passing my column, which is partner. My title is distribution of gender for churned customers. My hue is gender. So this basically is partner versus gender graph. Okay. Partner versus gender graph. Now, what do you infer from this? You can see that people who don't have partners, female customers who don't have partners are more likely to churn. Male customers who have partners are more likely to churn. So again, these kind of insights you can infer. Similarly, I am plotting the same graph for non-churners. And this is what the graph is for non-churners. That people who don't have partners, most of the non-churners are male, right? So churners are female. You can see. So most of the people who are female and having no partners are more churners. Now this is an insight that we got from here. So initially we got some insights like this, right? People with no partners are more likely to churn. But now I got some further insights that I have to be very specific. Female without any partners, female with no partners are more likely to churn than males. So that is my updated insight. So I'll probably update this insight. I'll not be very specific. I'll not be very generalizing that people with no partners are more likely to churn, but rather I will tell female with no partners are more likely to churn, because that is what my graph is telling me. Similarly, you do it for other things. Payment method. So this is a churn graph, distribution for the churned customers, and this one, payment method, distribution for the churned customers. Now we all know that people who are paying via electronic check are more likely to churn. That's already a known insight. Here also it's quite evident that electronic check, the number of churners are high. But one important insight that we are getting here is Even though the credit card transactions are less, but more female are into churning. So one more additional insight here will be, I would note it down as an extension of point 4, maybe point 4.1, that female who are paying via credit cards are more likely to churn automatic transfers. Now, I'm not inferring anything, but this is what the data is telling. So, female who are paying through credit cards are more likely to churn as compared to males. Other than that, even in bank transfer also, female are little bit more in number as compared to males, but mailed check almost similar, almost 1:1. Here also almost 1:1. So this is a major insight. This is a medium insight. Similarly, I will do it for contract. For contract, I don't see huge impact. Male and female are equally distributed. Okay. But in the 2 yearly contracts, more males are likely to churn. But yeah, this is not a great insight. So I'll skip it. I'll do it for tech support. And similarly, you have to do it for other things. Now, just imagine how many combinations of graphs there will be in terms of bivariate. If you have 20 columns, in univariate you can simply plot 20 graphs. But you are plotting bivariate analysis, so you can imagine how much combinations are possible. 1 with 2, 1 with 3, 1 with 4, dot dot dot, 1 with 10, and same 2 with 1, 2 with 2, 2 with 3, and goes on, right? There will be a lot of combinations. And similarly, if you jump into trivariate, four-variate, or multivariate, you can imagine how many total number of graphs there will be. And that is one of the reasons we consider EDA to be one of the most important steps and one of the most tedious steps, because it takes a lot of time. And again, it all depends on the client's requirement. If your manager tells you to perform EDA in 1 hour, it is possible. If your manager asks you to perform EDA in 1 day, it is possible. If your manager wants you to perform EDA for 1 week or 1 month, that is also possible. 1 hour or 1 day could be less EDA. You might not waste a lot of time in cleaning the data, probably will jump into some univariate and bivariate. If you get more amount of time for EDA, you can probably deep dive, do some mix and match of multiple columns, numerical with categorical, multivariate. A lot of insights can be gathered in that process as well. So overall, that's all about bivariate analysis. You can just simply play around with this function, pass multiple columns, multiple hues, and just cross check and gather as much insights as possible. So that brings to a conclusion of this particular exercise on EDA. I hope you had a great understanding on this particular use case about churn analysis. The conclusion here are very less. We have drawn more conclusions on this paintbrush as compared to what is here, but again, I'll keep it as an open assignment to you. Probably you can do further analysis and come up with hundreds and hundreds of conclusions, hundreds and hundreds of insights. Apart from that, as part of EDA exercise, it is also recommended that you create an end-to-end report. A report that summarizes your EDA task, because ultimately you will be showcasing this to your manager or to your customers who might not understand the programming language. So a report is definitely important. I have, however, created a report. Probably I will show that report as part of the next video, and I will just explain you how I created that report, which will give you an end-to-end idea on how reports are created, how presentations are created, that will automatically do the data storytelling part of your entire analysis. So we'll go through one of the EDA reports for a different EDA use case, for a different case study. So the case study was credit card defaulters analysis, where we have to analyze the different credit card defaulters who have been defaulter in the bank. They have not paid, or they have missed out their payment and become defaulters, and so on. It's a different use case. The use case that we were going through practically was churn analysis, but this EDA report is for another use case. But however, this report will give you an idea on how to build an EDA report. Based on the ideas, you have to create the EDA report firstly for the churn analysis use case that you have recently studied. Apart from that, you will also have to work on multiple other EDA use cases, and you have to create reports. A report should always start with the business understanding and overview. Business understanding is nothing but what the report is all about. What is the use case? Then it comes understanding the data. Whatever you have understood from the data, you should start writing it down. First of all, if your use case is having a target variable, which in the case of churn analysis, yes, there was a target variable called as churn column. So you have to write down your insights. What are the findings? The data is highly balanced or not, and so on. Missing data intuition. What do we do in missing data? In your use case, how many missing data did we have? How did you impute the missing data? So in the churn analysis, if you remember, total charges were having 0.15% of missing data, and we dropped it. So you have to write down those things here. Initial intuition from the data. In our case, again, there were no null values, but we understood that total charges was not in the format that we expected, hence we converted into numerical attribute, and we got around 0.15% of null values, right? So all those things has to be jotted down. And then comes your analysis part, the categorical analysis with all the graphs and the findings in the page. Whatever findings you have, you can just start mentioning them, and it goes on. Graphs, findings, graphs, findings, graphs, findings. So it gives a idea to the person who is actually watching out your report. They will be able to understand, they will be able to relate the graph and what's mentioned here. Now, for example, in this particular graph, we have name education and we have name education type. You can see the findings are most student loans are for their secondary education or higher education, right? It's quite evident. So you have to write down your findings and plot your graphs side by side. That gives a good understanding about what's happening, and it goes on. So we have done the same thing here, graphs and insights, graphs and insights. Similarly, do it for the numerical analysis, graph findings, and so on. If you have performed any other activities like heat maps or correlation maps and all those things, everything has to be a part of this report. And finally, you have to complete or summarize your report, summarize your EDA with final thoughts. Final thoughts should contain all the insights that you have found out. Now, for example, in your EDA case study, one of the insight was monthly contractors were more likely to churn. Female customers with no partners are more likely to churn. People who are paying through payment method as which one? There was one of the payment methods, electronic check. They are more likely to churn. Female customers who are having credit cards are more likely to churn. So you have to write down all your final thoughts as part of this particular slide. And then you can finish your PPT or your report just by a thank you slide. That's all about this particular video on how to create reports. I wish you all the luck. Please go ahead and prepare an end-to-end report for your churn analysis use case, and further you can take your learnings to the next step by working on multiple EDA assignments or working on multiple EDA projects. There are multiple EDA projects on the web. Go ahead, practice, and the more you practice, the easy it will be. for you to understand the concepts. That's all about this particular video. We are winding up the EDA sessions here itself. Thank you. That's all about this particular video. It was long, but I'm sure it was informative. In case you are confused what are going to be your next steps, how do we leverage this particular learning and create a portfolio project, reach me out over LinkedIn or even in the comment section. I go through each and every comments. In case you need any project ideas, I can also help you on that, of course, free of cost. And whatever you feel like, if you are going to be a data analyst or a data scientist, or you are going to be an AI engineer, let me know in the comment section. That's all about this particular video. Keep loving, keep sharing this channel, and don't forget to like, share, and subscribe. See you in the next video.